And finally, ladies and gentlemen, DevOpStars 2022 is live. That's a great pleasure for me because we was working on this event for I don't know months, maybe half of a year to prepare everything, and we are hoping to surprise you today because DevOps develops really fast. It goes really fast, and new technologies, new approaches, know-hows, or some presentations of new tools. That's what we are going to present here at our event today. Thank you very much to everyone who joined here today. And please let me know where you now. Just write in chat. I am in this country or this city or this even room maybe, because I'm now in Kiev in our office. And I have a green screen behind me, and you see this great picture, but it's just usual office here, and we'll maybe send some photos of backstage. Am I right? Yeah. Okay. Hope you'll enjoy this session, and I will invite here Debby, who is our brilliant community manager who created all these event and cooked it up together. Yeah, Debby, hello. Can you join us?
Hello.
Hi,
Yes, I
how are
can
you,
join you.
dear?
I'm fine, and you? How are you doing today?
I'm totally excited. And what do you feel today?
I feel very excited. Like, finally, DevOpsTars 2022 is here. Like I said,
Yeah,
we've been
wow.
preparing for over 5, 6 months, I guess.
Yeah,
And
yeah.
it's been a journey, but finally today it's happening. So,
That's
yeah.
that's yeah, cool. Thanks for joining us, and we of course waiting for some details. What's gonna be here in this next, I believe, 3 days, 3 days of this event.
Yes.
Incredible! Just how many speakers you have?
Currently, for this event, we have 51 speakers and more.
51 speaker.
Yes,
My
51.
God, my God. Yeah, and what else? What else you have?
Yes, and some of the speakers are from top brands. You won't believe we have speakers from Google, Microsoft, Vodafone, Amazon. Just think of any top brand, yeah, whole year, and you don't want to miss anything. So just sit tight and enjoy.
Yeah, cool. Thank you very much. And I believe we also will have kind of Q&A panel sessions, not just Q&As. Am I right? Can you
Yes,
more than the
yes.
information about that?
All right. So we have various blogs for you. We have Kubernetes, we have DevSecOps, we have many use cases. So just in case you've been wanting to learn something new about how to use some technologies, you're going to hear everything here today. So after every blog, we have a question and answer segment. So this is like an interactive segment between the speakers themselves. So you have the opportunity to ask any questions, that has been bothering you, or from any conversation or any speech from any speaker. You have the opportunity to answer every question.
Cool.
Yeah.
And Debbie, how many people registered on this event? Do you have any numbers?
Yeah, I think about 10,000
About
registrations.
10,000 registrations. Wow, can't believe that. It's quite like huge event actually, as
I tell
usually
you.
Geekle do. But yeah, cool. And people, please let us know where you now. And by the way, Debbie, where you are now? Tell us more.
I am in Ukraine. I am in Zaporozhye, Ukraine. So I'm watching
Zaporozhye.
you guys from Zaporozhye. Yeah.
Cool. Nice. And people keep sending us messages. So what you're expecting, what's gonna be crucial for you, and what you are interested to hear about. Maybe some topics or problems, or some technologies. You
Mhm.
want to know more. So yeah, just keep communicating with us, and because it's encourage us actually. Am I right, Debbie?
Yes, definitely.
So 3 days. What ideas of those days gonna be?
So we are going to have like a 3 day talk, and it's going to be for over 20 hours for each day. So the first day is for the beginner, and the second and the third day is for professionals. So if you are a CTO, CEO, or top developer, day two and day three is for you. You'll have a lot of things to learn, And like I said before, there are use cases, examples of how some technologies has been used and and has been successful. So just come and learn.
Yeah, cool. Look, and Debbie, as far as I know, you never worked with DevOps or some technologies before you joined Geekle.
No.
How did you manage to understand this and gather everything together?
All thanks to our program committee members. So I made a little bit
Yeah.
of research, but it wasn't nothing. Just because we want to bring you the best, the best topics in DevOps, we had to gather some, professional, top and skilled people in DevOps that helped us gather these topics together for you. So just be excited, because the things you're
Cool.
going to listen to in these 3 days is really going to change your life. So thanks
Cool.
again to our
Wow.
program committee members.
That's really high promise. I hope we will be really we'll be meeting these promises. Anyway, how many program committees you have?
We had 14 of them. 14
Oh,
of them
cool.
working morning and night, just to bring you the best topics.
Morning and night, and the days and nights. Yeah, cool. And I would like to thank all these brilliant people from program committee for that huge amount of work that you just done to together like this brilliant conference. I'm really excited to wait for the feedback from our community about this event. And people, please, once you get the feedback forms, it will be really important for us to get your feedbacks, for me, for Debbie, for program committee, to understand what was good, what was not really good, and how we can do even better events and create the next DevOps even better than this one. And of course, our sponsor. Now, I want to say huge thank you to our awesome platinum sponsors. Big shout out to Sysdig, to Nereligion, to JFrog for supporting this community and helping us actually to create this great event. And thanks to everyone who paid at least $1 for tickets, because you help us to create and develop this community. Thank you very much, and please continue and keep support us. Yeah, we described everything we're gonna show. We talked about our speakers and the program committee and sponsors, and no more chatting. Let's go straight to the point and invite our first moderator. Are you agree, Debbie?
Yes, I agree.
Yeah, people, enjoy. Happy to have you here. Bye bye.
Goodbye.
Hello, everyone. So I'm going to be the first moderator of this DevOpStars Summit today. And I was actually part of the community, board. And so my name is Gaëtan Bloch. I'm from France. I'm a technical architect and team lead. And I'm also going to do a speech on the second day for the pro tracks. Next, we will have a small announcement about one of our sponsors, Sysdig,
and now we want to say a huge thank you to one of our platinum sponsors, Sysdig. So the Sysdig Security DevOps platform provides security to confidently run your containers, Kubernetes, and cloud. Secure your build, detect and respond to threats, and continuously validate cloud posture and compliance. Maximize performance of your product and availability to monitoring and troubleshooting cloud infrastructures and services. Sysdig is a SaaS platform built on the open source stack that includes Falco and Sysdig OSS. They open standards for runtime threat detection and responses. Hundreds of organizations rely on Sysdig for security and visibility. To use their free trial, sign up via the link that we will post in the channel. And you can join right now and start for free.
Okay, so next speaker will be from Italy, Cristian Prevedello. I hope I'm pronouncing right. And he's a chief architect at Prevenet. So Cristian is an hands-on chief architect fully dedicated to build Prevenet private cloud infrastructure through custom-made DevOps tools. used to deliver and roll out highly performant scalable applications based on reactive microservices and Kubernetes. So I'm going to put Cristian to the stream. And you're in, Cristian. How are you?
Hello, good morning. I'm good, thank you.
Okay. So everything is all right for you? You're pretty well prepared for the presentation, and
Yeah.
Okay, so I hope I didn't pronounce your name wrong and your company. And
okay.
So I will give you the hand, and you can continue with your presentation. Thank you.
Okay, thank you very much. So please welcome to my session. This session is about how we secure legacy applications and microservices deployed inside Kubernetes with HashiCorp. Traditionally, what companies did was to build a perimeter around their applications in the data center that was basically a firewall, and this perimeter was used to keep outside threats and dangers. However, the problem with this setup was that as soon as an attacker made a breach inside your data center, you were screwed up because they could access all your assets that were inside your data center. So in the past few years, a new methodology was adopted that is called Zero Trust, where of course you still have the perimeter outside to keep outside your threats, but anyway, inside your data center, you don't trust anymore anybody that they claim to be what they claim to be. So instead, each single asset, each single component must be identified beforehand. It must be authorized to access a specific resource on the system and so on. In this way, even if an attacker manages to breach your data center and they get to access a single system, they don't have by default access to all other components, but their, let's say, the damage they performed is still limited to that single specific component. So what it means when you have hundreds, let's say, services, components, applications that must talk together. We have several hundreds of customers, and I think we have something like 400 different applications running in our private cloud. So you can't do that. You can't manage by hand all those identities and all those rules to authorize. So we identified a solution that could help us, that is HashiCorp Vault. What we wanted to put in place is, of course, Zero Trust that I just explained for services, devices, but most important for humans as well. Humans, not because we don't trust our employees, but some credentials could be stolen, so we don't trust anybody in our data center when it comes to security. And we can't just secure modern and new applications that are running in a cloud-native infrastructure like Kubernetes, but also the weakest link, that is the legacy applications, must be secure as well. Otherwise, it's basically having no security at all. We go back to what we had in the past. Yeah. So I'm sorry for the echo because I don't know. It's not the first time I run my sessions from this room. So anyway, I try to speak not very loud. So what we did is we have to secure legacy applications. We have to put strong governance and controls on what we need to authorize. We also had to put fine-grained policies to exactly authorize a single applications to access other assets and so on. And we also wanted to be highly automated. We didn't want where bottlenecks, and we wanted to be to have a high speed of delivery and configurations of our applications and configurations. So, what we did was to set up 2 clusters, one for staging, where we used to test new configurations and to support all non-production environments. And we have another cluster that is just for production, and it's not used by the users, it's not accessible to end users. It's completely segregated to the server network, so it's not, let's say, exposed to something other than the server networks. When it comes to security, it's not just about protect the information that is not disclosed, but it's also about availability. So your systems must be uptime all the time. So we configure a 3 nodes Vault cluster and with console backend, and each component uses mutual TLS to identify with other components. So Vault cluster, when needs to talk with console, authenticates the connection with mutual TLS and so on, to provide a single virtual, let's say, to provide the connection to the systems, to the active node. We use Keep Alive. From an operating perspective, our DevOps, they configure, they deployed, and they configure on a day-by-day basis the system with some Ansible playbooks built around Vault Clip, and everything is treated, is managed as a configuration as a code that is versioned in Git and is reviewed before being deployed into production. So what happens that whenever a user needs to configure something in Vault, they commit a YAML request into our GitLab repository, and GitLab, and then through a webhook, the request is processed by our Kubernetes operator. It could happen that the request must be approved by a DevOps or a secret owner, and then the Kubernetes operator send an email to our DevOps, to the secret owner, and then through a specific UI, they approve or enter the secret, and then the Kubernetes operator goes to Vault or to the target system to update the secret or set the new secret. So this is very important because the devs, they never have access to any secret, and more often, neither the DevOps, they have access to the secrets, because these secrets are managed by the Kubernetes operator and brought on board to the target system directly without disclosing the secret in any way. So what we secure in the past, and what we are currently securing, we secure data in transit with TLS, so HTTP traffic between services or the end users. We secure the connection between services and databases. So we use Postgres, and to create a connection, a secure connection with Postgres, we use BG Bouncer, or we use Envoy for Mongo, and the same applies for Kafka, because to connect an application with Kafka, let's say we have some problems to put all together. If we have an application that needs to talk with Mongo, Postgres, and Kafka, bring inside the same application all the libraries that were compatible was hard enough. So what we did was to configure some sidecars outside the application, and the sidecars are managing the connection, the secure connection with the target database. The TLS infrastructure, the private key infrastructure, is also used to authenticate the services. So we don't use just for secure the transportation of the data, but we also use to authenticate the single specific application to those databases, namely Postgres, Mongo, and Kafka. When we can't use a certificate, because the system doesn't support that schema, that kind of authentication, we revert back to username and password authentication, and we have those users created into our Active Directory, and here we enforce a password rotation of 1 day, just to rotate very often the password. Just before we had Vault in place, anyway, we had proper authentication between web applications, and we are using GitOPs to authorize and identify incoming requests. And keys, we moved the keys from local storage to the application server or a single Docker image to Vault into a specific key value engine. And moreover, we also use key value engine to store everything else that can't be dynamic. Of course, we have integration with our customers or our suppliers, and we can't just change those secrets on the fly. So we also use Vault as a storage to store everything else that must be static, let's say. When dealing with certificates, the priority key infrastructure is something very important, because it outlines how your certificates are issued, are managed, which are the different organization units and organizations that are supported by key infrastructure. So we have something very important that is supporting our Kubernetes clusters, but we also have many different, let's say, roles, how they are called in Vault, to support different types of certificates. For example, we have a specific organization unit to issue certificates for our Mongo service or our web applications. So we are talking here about TLS client certificates used by the web application and so on. Each role, of course, is configured and can be used only if they are authorized to a specific asset in our system. When it comes to certificates, of course, you have to rotate them sooner or later. So here we are moving to, in some scenarios, we are rotating certificates on a monthly basis, but we are not there yet for all our infrastructure. More often, we are 1 year or 6 months. So we still have the management of the rotation based on our old GitOps infrastructure that is based on Jenkins and Ansible. The next year, during this year, we are planning to move all this stuff as an operator to Kubernetes. But as today, we have this Jenkins-based job that basically go to our GitLab repository where all the requests are stored, and for each certificate that was issued in the past, they go to the target system and they check if the certificate is due to expire. If the certificate is expiring in the next 30 days, then we issue a new certificate and we replace the old certificate with the new one and we start the application. We do whatever is required to perform the proper housekeeping. And of course, we notify the certificate owner that was replaced, so they are up to date. Every day we receive a complete report of the status of all our certificates, and we send a notification to the certificate owner 5 days in advance, just to inform them what's going to happen, because we don't want to overlap to different maybe maintenance operations in the same time. So we are recruiting certificates and maybe we are configuring something else in the target system. So we could clash and create some problems. In our data center, what we deploy? We deploy services in Kubernetes that are Java, Scala, and Python based. And here we have the best of security because each application is segregated at the container level. But we also have all the legacy applications that are basically running into Jakarta application service. And here, the segregation happens at a virtual machine level. So if we have multiple applications running inside the same application service and one gets compromised, all other applications are compromised as well. So we put into the same virtual machine all the applications within the same tier and within the same customer. We don't mix different tiers and we don't mix different customers because if we compromise one customer, of course, we don't want to compromise another customer. It must be segregated. So for each application, we have a dedicated key value area involved where that application can put their secret stuff. We also have a public key value area where they can put some public information like the public keys of certificates or public keys for GWT signature. We have a dedicated policy to grant permissions to that specific application for what concerns the Vault. And of course, we have policies that are more like templates because we don't want to mess up and work very much on policies because they are rather tricky and they could, if they are not configured correctly, they could expose data. So we try to write one policy and reuse that as much as possible. And each application must be enrolled beforehand. It's not possible to just deploy an application and this goes up and running without before approving that enrollment into Vault. This is an example of enrollment. It's just a YAML file that the end user, the developer, can push to our GitLab and must be reviewed by the DevOps or team leader, or it depends on which branch of the developer is located. We have different processes of the review processes in our customer. So here we have the name of the application, which is the environment, which capabilities are required by this application. This is running Kubernetes. It requires a console because maybe they need, in this case, service discovery facilities provided by console. We also need AD means Active Directory because they need a username, I don't know, to connect to another system. And here we provide some information about the Kubernetes capabilities. So we say that this application is running into the architecture namespace, which is the console policies that must be used by this application when it comes to connect to console, and which is the name of the LDAP of the Active Directory user that needs to use. So the application policy, I think, it's the most important because it states what can be read, what can be done when this application involved. Here, most applications, they are read-only because they don't need to write anything to Vault. So here we are saying that they can read this key value and from this path. As you can see here, we have some templating going on because the policy is just one. We have this application that is a multi-customer application. We deploy the application for different customers, but we don't want to replicate the policy. So we are just using Vault templating facilities with metadata stored into the identity that is stored in Vault. In this specific scenario, we are using the customer name. So we can't access different customer secret data from the same application running into another customer. Kubernetes was configured, how it is configured with Vault. There's a specific authentication method within Vault where we put in trust the two clusters, Vault cluster and Kubernetes cluster, and each pod has a dedicated service account that is used to authenticate in Vault. And that's the piece of information that is used to identify from a Vault perspective who is performing that code. We use the projected service account token because we want to rotate the token very often. So we track the service account token that is static very carefully, and we don't want to disclose that to anybody, not even to the application itself, because with that we could impersonate the application. So in case of, let's say, a developer that is logging the service account, if they log the projected service account, they can impersonate the application for a limited time. But if we disclose the real service account token, they could impersonate the application forever. We have used Vault Injector just to provide the secrets to the pod. So we don't, for Kubernetes microservices, we don't have any awareness of Vault because they are reading secrets from the file system inside the container, and the Vault Injector is creating these secrets inside the container and is rotating the secret as required. So if a certificate is expiring, Vault Injector on its own will rotate the certificate, and the pod, the container, will pick up the new certificate as well. We make an heavy use of sidecar containers and Void EPG bouncer to offload the TLS connection with external systems. And I think that this is the most important part. The required secrets must be declared in Helm values. We are using Helm to generate the YAML that are deployed to Kubernetes. And so even if we enroll the application, it is deployed, but we didn't properly describe which secrets we need. The application will work. So we have different layers of review and, let's say, checks that prevents that a misconfiguration could be turned into a security issue. So even if I approve by mistake a wrong enrollment, then we also have a different part of our, let's say, infrastructure, our team that must approve the required secrets as well. So security is never one approach or one measure. It's more a mix and an addition of many different parts that comes together to perform a comprehensive protection around our data and applications. Jakarta application, they are our legacy applications, of course, and here we use the GWT authentication method. And compared to Kubernetes, where the GWT generated by the service account is fully automated by Kubernetes, here we had to bring on board the application server on our own. So we are using our GitOps platform that is generating these GWTs and bringing on board the system properties of the application servers. And here, since we didn't want to adopt Vault Agent and deploy all those Vault Agents into our application servers because it was somehow troublesome to monitor and manage all the stuff. Here we enhanced all the existing clients to use Vault. All interactions with external systems, they go through some kind of clients, And so we put in place inside these clients the logic to access in a transparent way Vault. In some rare scenarios where we had some rather picky customers when it comes to security, we used sidecars in the same virtual machine or a different machine, so it could be replicated what we have in Kubernetes inside a virtual machine. But that's not exactly easy to set up, to monitor, to maintain. So we try to avoid and instead push to move this application, this service to Kubernetes. So after this journey that started 2 years, almost 3 years ago, what changed in our way to process these secrets and the security? Secrets must be requested, and they are reviewed, and they are approved, and they are tracked. So we don't use anymore something unstructured, something that isn't into some kind of database. And our database in this case is GitLab, is the source of truth. We have a centralized point that is Vault, where each secret is protected by fine-grained policies. So we have a great way to segregate different pieces of information and follow the least privilege principle. Don't give anything more than you actually need. I think the most part is, another very important part is secrets are never disclosed, because in the past, secrets were being communicated to different colleagues to put a specific password onto the system, but with our system, secrets are never disclosed because they are 90% managed directly by Vault and our operator, and they never leave the protected perimeter. It's much easier to rotate such secrets because we are heavily using certificates, TLS certificates, and they are by default, let's say, they promote the rotation and a way to don't think that the secret will be the same forever. And of course, we are using Vault auditing infrastructure where each single operation is tracked and audited. So I guess that's the way to go to properly manage and adopt the zero trust principle to improve the security. That's it. So I hope you find some good opportunities to improve your center, your security, as well as what we did.
Thank you, Cristian, for a very important talk on security and for applications in container in Kubernetes. And what I liked about the solutions is that all the tools you used are open source and free. And especially, I'm a big fan of HashiCorp products, especially, well, Vault, Console, Terraform. You probably have used it. So thank you very much. And we'll see you at the QA session after.
Yeah, I will be there.
And I apologize again for cutting you in the middle. Sorry.
No, don't worry. My apologies.
Thank you. Talk to you later.
That's all. Bye-bye.
So next we have another announcement by our sponsor.
And now I want to say a huge thank you to our friends and our sponsors at Neurolegion. Thanks once again for joining us and for sponsoring this event. And just a couple of quick words about their API and their security testing scanner. What's so awesome about their product? So basically, it's built by developers for developers, and it helps you to integrate your security testing, gives it into the hands of your developers and your QA engineers and DevOps engineers. And It built for developers. It produces no false positives. It's easy to use and fast to integrate with your CI/CD. You can test your applications and APIs, SOAP, PRAS, GraphQL, you name them. And you can do it on every build, basically. So no manual validation. You don't have to go through the finance. Once again, it removes false alerts and human bottlenecks that cripple your rapid releases. It will speed up your releases. And also, it's developer friendly. It has the remediation guidelines are very simple, and you can start fixing your security issues. You can start fixing security very often now. It makes it so easy. So have a look into their awesome trial. And also, we will announce a hands-on workshop for where you will actually install it, register. You will receive a free trial. And basically, you will have a hands-on workshop. You will do the repo, you'll set up the scanning, and in just a couple hours, you will learn some awesome tricks that you can use in your DevOps day-to-day practice. Thank you, Neurologian.
Okay, so let's move on to the next speaker, Piotr Zaniewski from Germany. He's a senior DevOps architect at Comfort AG. He's passionate about cloud-native technologies and containers, Kubernetes, public cloud offerings, and DevOps. And today it's a pre-recorded talk. It's gonna be on Kubernetes certifications and how to take your career to the next level.
Hi everyone, really excited to be here and talk to you about Kubernetes certifications. I will be talking about my journey to get the certifications. I will be sharing practical tips, how you can boost your career by getting the certifications. I'll be showing some learning resources and tips and tricks. So let's get started. Let me share my screen real quick. All right, I hope you all can see my screen. So first, a little bit about myself. My name is Piotr Zaniewski. I am really passionate about cloud-native technologies, especially Kubernetes. I've been working with Kubernetes for 5 years or so. I really like containers technologies, Linux, and I am an avid fan of multi-cloud. You can find me on Twitter. You can reach me per email or check out my GitHub. I also regularly blog about all things cloud native, also Kubernetes, and tips about how to pass the certifications. You can find my handle on Medium here on the screen. By the way, this presentation will be available for everyone to download and go through. There's plenty of links and all the goodies. All right, so let's maybe start by asking, why would anyone want to get certified? Some of the answers might be plain and obvious, but some not so much. So if you are at the beginning of your career, currently, it's really, really great to be in a cloud native space or generally in software development space. There's a lot of job opportunities, but there's also a lot of competition. So if you're considering moving into cloud native or kind of a little bit more infrastructure roles where you will be working with tools like Kubernetes or Docker, then certifications make a lot of sense. It can fast track your career significantly. If you're just starting, you maybe are a junior developer and you're looking at all those tools, Kubernetes certifications are a clear sign to potential employers that you are capable of learning, you're interested in learning, and you actually have some practical skills, especially after finishing Kubernetes certifications. You might also stand out, right? So getting recognition, whether it's from your current employer or from community, is something that feels good and definitely helps your career. If you already work somewhere, then changing, often you might want to, for example, change from being a developer to being a more infrastructure-minded person. Then certifications communicate to your employer that you actually are serious about it, and they significantly increase your chances of getting promotion or laterally moving to a different position. Now, not all the certificates actually teach you practical skills. There are quite a few certificates, especially around the cloud industry, that are more or less similar to school tests. So you need to know the theory, but not that it doesn't really give you that much of a boost in terms of learning practical skills. This is different for Kubernetes certifications. We'll look at the different certifications in a while, but Kubernetes certifications are unique in a sense that the exam that you have to take is practical for 3 out of 4 certifications. And last but not least, imposter syndrome is real. We all felt like that one way or the other, me including, and certifications really gives you this this assurance or confidence that your skills are really there. You know what you know, and you know what you don't know. All right, so a little bit about job market. So you could see this page. There's a page dedicated only to Kubernetes jobs. So they're consistently being added. This is a worldwide market. You can, of course, also look at LinkedIn or other portals. Jobs with the keyword Kubernetes in it are definitely in high demand, and this will only continue to grow. So you can just look at this page. Again, links are all, some of the pages are embedded within the presentation, and for some of them we have links. All right. So we couldn't really talk about Kubernetes without talking about CNCF, which stands for Cloud Native Computing Foundation. CNCF is body that is a governing body that has all the open source, not only open source, projects with thriving communities behind them that are pushing forward cloud native and cloud computing landscape. Kubernetes is obviously among them. It's one of the first projects that got graduated. Here you can see all 16 graduated projects, meaning that those are the projects that went through exhaustive CNCF vetting system, are supported by large and diverse communities, and are used by many customers in production. CNCF have various stages for open source projects. We're going to look at this in a second. But so you know that investing in Kubernetes is really a safe bet, and the time you spend learning and working with certifications and attempting to pass exams is worthwhile. Right, so it wouldn't be a presentation about Kubernetes without looking at cloud native landscape. You can even see it doesn't really load that well. So what is cloud native landscape? Cloud native landscape is really a host. It really boosted my is designed for administrators. It is much more difficult path. Multiple choice question. You're also investing in all those parts of this ecosystem, and it's really important to understand that it's not only Kubernetes, it's all of those other tools that are also integrating seamlessly with Kubernetes and are actually part of it. So you are not only investing in Kubernetes, but you're also investing in all those adjacent tools that you will learn. All right, so let's jump into certifications themselves. There are currently 4 certifications that you can take. One of them, the entry-level Kubernetes and Cloud Native Associate, is actually a theoretical exam with multiple choice questions. where you can learn and kind of show that you know what cloud native is, how do we reason about projects within cloud native space, and what are different definitions, common vocabulary, patterns, and so on. It's a very good certificate if you just want to start and show that you are ready and willing to embrace Kubernetes and the ecosystem and follow the certification path. Now, all the remaining certificates are actually practical exams. I'll talk about this a little later. So we have CKAD, which stands for Certified Kubernetes Application Developer, which is obviously aimed at developers. This certificate is really for people that develop cloud native applications. One way or the other, you will deal with containerization, you will be exposed to projects like Helm, you might need to write some YAML, which we know and love. Next certificate is CKA, which stands for Certified Kubernetes Administrator. This certificate is designed for administrators. It is much more difficult, it's broader in scope than CKAD, and it teaches you skills like maintaining a cluster, managing it, and so on and so forth. All right, CKS is advanced certificate for people interested in security, and the prerequisite for CKS is a successful CKA certification. Now, CKS is really challenging exam, but all of them really teach you something. But out of all those three practical exams, I find CKS the most challenging and the most interesting in terms of learning. It really boosted my understanding of Kubernetes and cloud native security. All right, so let's move a little bit here. So how to know what is going to be on an exam? One of the best sources is obviously the CNCF webpage, but in this Git repository, you can actually see different curriculums. So here we can see, move this a little bit away. Here we can see curriculum for CKAD, CKA, and so on and so forth. So if you look at KCNA, apologies, then in KCNA, we have those kinds of topics that you need to be familiar with. And things like Kubernetes resources, architecture, those topics are very well documented within Kubernetes community. And you can find a lot of interesting resources to help you learn. Fundamentals of observability, a little bit about cloud native application delivery, the space where I am invested a lot, container orchestration. So all those are basics, kind of like understanding what's happening, what is Kubernetes, how things work. And there's a lot of resources that you can use to pass this certification. It's relatively easy. Right. So now let's move to exams themselves. So exams are challenging. First of all, so I'm talking here only about the three exams, leaving this KCNA aside, which is a slightly different and easier exam that is based on like a theoretical typical tests, whereas both CKA, CKAD, and CKS are practical exams, meaning that you have to actually use command line tools like kubectl and other Linux tools and Linux built-in facilities to perform different actions on Kubernetes resources, on the clusters, and security resources, and so on and so forth. Those are challenging exams mostly because they are time-bound. There are various times for each exam, and those times are really steep. So you really have to know what you're doing. You have to prioritize well. I ran out of time on my first exam, so this is a really challenging time slot. So you have to be really efficient and quick. All right, so let's move to tips. What can you do to really start learning and increase your chances of passing the exams? So I'm really a believer of trying things out and having a practical experience, followed by understanding a little bit deeper how things work within maybe architectural diagram or some kind of in-depth searching or reading. But I really like my first experience is just to be seeing how things work and kind of trying to split how certain parts work, why they work in a specific way, and so on and so forth. So here you have a list of potential playgrounds with Kubernetes. Some of them can be locally installed on your PC or MacOS or whatever you have, and some of them are remote. All of them are free, which is really great. So I would say if you just start and want to like look what Kubernetes is and have an experience with having interacting with kubectl or kubectl command line interface, then I would highly recommend just activating one of the remote clusters. I will show in a second one of those. But when you are going, especially for CKA, I would advise actually installing a cluster with Vagrant, because there are a lot of tasks that are relatively in-depth and they require access to, in this case, virtual machine resources and in-depth Linux resources. All right, so let's look at one of such examples. So I really like using Katacoda. So Katacoda is a free service from O'Reilly. Katacoda was a independent company acquired by O'Reilly a while ago. And as you can see here, if I type Kubernetes, you can see there are Kubernetes fundamentals. So just clicking start here, and Kubernetes fundamentals gives me these options to have just a playground. So if I start scenario, then we are not going to go through all the scenario, but you can see here are instructions, what you should do, and you have all environment running virtually in cloud just for you to play around with Kubernetes. There are often explanations and kind of step-by-step practical experiences you can have with the cluster, which is a really great start. I have my own courses on Katacoda as well. Some of them are targeted to learn to teach a specific Kubernetes skill, working with deployments or pods or services and so on and so forth. I highly recommend starting here, but all the other resources I listed are also valuable, and you can find something for you for sure. All right, tip number 2. Each exam allows access to Kubernetes documentation, which is really critical, because without this, the practical part of the exam would be impossible to pass. You just cannot remember all the flags and commands and so on. So because we have access to Kubernetes documentation, and this, by the way, means Kubernetes webpage itself, but also all the Kubernetes domains on GitHub, domains and subdomains on GitHub. So this is very important, because to actually know how documentation works and use and know how kubectl commands work. So I'll show a couple of resources, but the first thing to do on every exam, which helped me a lot, is just to copy paste those commands, aliasing your kubectl command, and then creating a completion in Bash, which just helps you type much faster, and time is really critical on those exams. All right, so next resource. This is just an example of my webpage that I host, and within my webpage, I gathered sample commands that I found very useful on each exam, and here you can see this resources. There's a lot of potential commands that you can just simply memorize, and they really helped me save a lot of time during the exams. Now, you need to know Kubernetes documentation very well in order to pass the exam. So how I approached it, I actually created in my browser a bookmark folder, which is arranged in this way. By the way, I shared these bookmarks in one of my blogs, so you can just copy paste and have the same folder. This is really helpful because if you have a question, let's say, how do I, the task in Kubernetes might be, you need to create a network policy, which is a very common task within all the exams. So typically you would just open the web page, type network policy and try to find appropriate space where you can copy the YAML from. Whereas in this case, I just click the folder, click network policy spec, and I immediately am redirected to a raw YAML where I can copy network policy from. So very important to work with those resources. And by the way, this is a fully transferable skill, meaning that you can actually use this in real life. I'm using it very often when I work with Kubernetes. If I need to know something or need to copy somewhere some kind of commands, I just use those links real quick instead of searching the web page by hand. So practice finding information on Kubernetes documentation page. It's really critical for success in your exams. The tip number 4, know Vim or Nano editors very well. Very often you have to edit YAML files, you have to edit configuration files, you have to create files. So knowing Vim, in my case, I selected Vim, but both editors are available, Nano or Vim. Funny enough, since I started using Vim and started learning a couple of years ago to my first exams, I actually stayed with Vim, and I moved from VS Code to Vim as my primary programming environment driver. So it's a really powerful editor, but that's a side note. So whether you choose Vim or Nano, it's really critical to practice working with them. What I used to do is just try to edit files and just make sure I am efficient in Vim. So there are some shortcuts that are very useful and other tips and tricks within Vim specifically, if you're interested. Right, one more tip is questions priority. So for all the questions, if you have to perform a task on a separate cluster or on a separate namespace, typically those tasks are isolated. So you can mark a question that you're not really sure about, or you can develop a strategy by saying, I am going to target the questions that have a higher weight, which means that they have a higher percentage of points when they are successful, and then you can mark those that you want to come back later, just for coming back later. So it's a really good strategy. And final tip, stay calm. This is actually something that I struggle with. Exams overall are stressful experiences, whether they are at school or whether you have them online like that. But remember that buying, when you purchase an exam, it comes with a free retake. So try to remember that even if you feel that you're running against time or you're not happy with your results, still try to remember, observe, and remember that you will always have a free retake. So take a deep breath and try to focus. All right, so let's move quickly to learning material. There's plenty of learning material nowadays. It wasn't that much when I was passing the exams, but now you really have a luxury of just picking and choosing whatever learning material you want. I can recommend a few, and I will, but that doesn't mean that there are no others that are amazing. I might not even be familiar with. So I recommend those resources. So first of all, I highly recommend CodeCloud. CodeCloud is a company started by Mumshant Monabath, and those guys are great. They really have a very highly interactive courses, and really highly recommend checking them out. They are not, you have to pay a subscription, but maybe your employer can help you, or maybe they have student discounts. So this is not a free service, but extremely high quality. So basically, at the beginning, I just used those services, and that helped me pass my exams. Just Me and Open Source. It's a YouTube channel, so obviously free. YouTube channel created by Venkat, if I'm not mistaken, if I'm mispronouncing his name. And this is just a great resource especially for CKA exam. He's just explaining in a really approachable way how to create different resources, how to configure clusters, and so on. This is really, really great content. Killer SH, I'll show this in a second, also very good idea. Civo Academy. Civo is a company that I would classify them as a cloud provider. There is a small cloud provider focusing on Kubernetes, so they kind of only offer Kubernetes as a service. Really smart guys. They recently opened Civo Academy, which is a set of free resources that you can use to learn Kubernetes. Really, really, really great. And obviously, there's tons more that I couldn't mention. And my guide, this is the domain I have, is just more about my learning notes from various certifications, not only Kubernetes, but also various cloud certifications, tips and tricks, and so on. So this is something just for me that I share with everyone. So if you find it useful, that's great. All right, so here is CodeCloud. Just real brief. As you can see, that's the Kubernetes learning path. Where you, as a prerequisite, you learn Docker, and then you have Kubernetes for beginners, and then you have advanced scenarios for CKA and CKAD, and they also have a training for CKS. Killer SH is a really interesting service. You get actually access to this page for free when you purchase the exam. I don't remember exactly, but I feel it's something like 24 hours before the exam, you can actually train here. And this is like a playground that simulates the exam environment. And the questions here, or tasks that you have to do, are actually harder than they're going to be on the actual exam. So really interesting service. Otherwise, they have a paid use as well. That's the Venkat channel with a really cool font. So you can see a lot of interesting videos, how to deploy cluster with kubeadm, and so on and so forth. And here you can see Civo Academy, where you can sign up and begin learning for free. And here is my page. So there's various certifications here. So, introductory content, and you have CKA, CKAD, and CKS help or helping material. All right, and this presentation is under this URL. It's completely free, open source. You can just download it, or just go through the same slides as I did, and all of them have links. So if you find it useful, that would be great. All right, so definitely you can do it. Exams are challenging, but they were well worth it. So I had experience with different technologies, and I have to say that preparing for the exams and passing the exams it was a hard work, but it was well worth it, and I've learned a ton while doing it. And I'm actually using this knowledge on a daily basis. So this is not an exam that is just for the sake of having an exam. So thank you again for your attention. I hope you found the content informative and useful. One more time, I highly encourage you to try and get the certifications. There are various ways how you can get the discounts. There are some promotion codes every now and then, or if you are currently working somewhere, you can ask your employer to get the certifications, to cover the certifications cost for you, and just keep learning, keep exploring. And I am also out there. If you want to connect on LinkedIn or Twitter or email, I will be happy to help you. If you get stuck anywhere, I intend to produce more content on my own, mostly in the format of blogs, but there's a lot of other existing resources available as well. But again, if you get stuck, if you need some one-on-one help, I'll be very happy to assist you or help you with whatever problems you might have. All right, thank you again for your time, and please do enjoy the rest of your conference. Thank you.
Thank you, Piotr, for this very interesting video about certifications in Kubernetes, which are sometimes difficult, yes. So before the Q&A panel with the speakers, we're going to have a short video with our sponsors, and here it goes. Thank
you. You can write the best code in the world. You can run the most complex systems. But things get really complicated when you have dozens of different technologies and hundreds of processes. Fortunately, it's JFrog to the rescue. Firstly, you need universal tools that can integrate seamlessly with all the build technologies in your CI/CD stack and all major cloud platforms, so you can start speeding up software releases without delay. Second, you need to automate every part of your DevOps pipeline, end to end. This will eliminate repetitive, manual steps while letting you enjoy much faster feedback loops so you can get higher quality releases to customers faster. Next, you need a proven way of catching potential vulnerabilities and license compliance issues, wherever they may be hiding in the DevOps cycle, so you can stay out of the latest security disaster headlines. And of course, you need the flexibility of a cloud on-prem hybrid solution that offers high availability, disaster recovery, and is easily scalable and enterprise grade, from code right through to production. The good news is that you don't have to look very far to find this. JFrog offers you an end-to-end DevOps platform for creating, managing, and distributing trusted software releases fast to anywhere in the world. It's why 5 million developers already count on our universal DevOps tools to do their job better, faster, and more securely. So wherever you are in your DevOps journey, let JFrog smooth the ride, automating your software delivery process. Learn more or get started right away by visiting us at jfrog.com.
Okay, it's me again. Then we are going to start the QA panel with Piotr and Cristian. So I'm going to add them to the stream. Hello again, Cristian.
Hello.
Hi, Piotr. Long time no talk. How are you, Piotr?
I'm doing great. How are you, Gaten?
Yeah, I'm great too. Thanks.
Awesome.
Your video about certifications was great too.
Thank you. Nice. I really appreciate it.
Okay, so I have a few questions from the audience and a few personal too. I'm going to start with a question for Piotr, mostly about certifications. We have a lot of questions about certifications actually because a lot of people are interested.
It's a hot topic.
This is a more general question. Doske Kubernetes certification is targeted to only engineers, you think, in your opinion, or managers who don't really have the technical skills necessary for it can get some value from it?
Yes. Right. Very good question. So before KCNA was introduced, so the associate certificate, I would say no, because the certifications are really in depth. But with KCNA, absolutely yes. I would compare it to if you have cloud certifications, Azure has, for example, AZ900, which is fundamentals and theory, and everyone, project manager, or non-technical person can definitely benefit from understanding cloud native concepts on a high level. So KCNA absolutely recommend for non-technical person as well.
Okay. Thank you, Piotr. I have a personal question for Cristian. This is from me. You talked about HashiCorp tools, so it seems you're using it. Since I'm a fan too, as I told you, in your projects, and have you ever used Terraform and interact it with the tools you presented, like Vault and the other ones?
Oh, well, we don't use Terraform because we don't have any public cloud usage. We have everything on premise. And so we are using heavily Ansible to configure and deploy our systems. We evaluated Terraform when we started to build how we could configure Vault. And Terraform had, at that point, 3 years ago, had some early stage plugin and facility to interact with Vault. But at the time, it was rather, let's say, immature. So we preferred to stick with Vault CLI and build around this Vault command line interface, something in Ansible. So the question is, I like Terraform. I know it. It's very nice, but given in our state of our infrastructure, we can't, let's say, switch to this new tool.
Okay, thank you for the answer. I have another question from the audience on the chat for Piotr. So are Vim and Nano hard requirement for YAML works, like for any kind of editing file edit? What's wrong with VS Code or even Notepad++? Well, I guess it doesn't work in the console. That's the main thing. But yeah.
So no, that's I should have clarified this on my talk. It's a very good question. So Vim and Nano are the only programs available during the exam. That's why you have to learn them. But of course, for your own workloads, absolutely VS Code, Notepad++, or Notepad itself, if you're really hardcore, go for it. Everything would work. But during the exam, you only have Vim or Nano available, or also like a built-in web editor. That's not really that helpful. So I should specify this is only during the exam, but nothing wrong and nothing against VS Code.
And mostly when you build a Docker image, when you share inside it, if you're on Linux, pretty much a lot of time you're gonna always have Vim and Nano pre-installed. Handling one of it is actually necessary when you're doing that kind of work, I think.
Right, exactly. And bindings for Vim, for instance, are also available on VS Code, so you can kind of combine both. But that's definitely a good point. If you are administering systems that you SSH into, like VMs, and there are not Vim, but VI available out of the box, and Nano as well. So that's a good point.
Yes. Okay. Okay, another question about the audience. Okay, this is more general question about CI/CD. Okay. What new CI/CD tools in 2002, I guess, would you recommend? If I can, I'd like to. I just started a new working with a new. It's not new, but it's incubating by the CF. I'm talking about Argo CD, which is a GitOps for Kubernetes configuration, and which I started using, and it's really, really useful. But yeah, let's have your opinions on what you're using.
So I'll start real quick. So Absolutely, Argo CD. You can also add Flux v2 to the same bucket. So GitOps tools. I personally use Flux a little bit more. There's a very interesting tool that is developed by a person who invented Docker, Solomon Hykes, and the tool is called Dagger. You can check it out on GitHub. It's actually a little bit confusing to me still what it does, but it's supposed to be an augmented CI automation process. So if you have a CI specifically on any cloud provider or GitHub, GitLab, they have their own specialities. They are different. So you kind of got locked in a little bit in the CI provider. The YAMLs are, specific to the infrastructure. Whereas with Dagger, you kind of get the abstraction layer on top of that, and you're becoming not locked in a CI vendor. Dagger does much more. I highly encourage you to just check it out. It was in private preview for a while. I believe now it's available for everyone to see. So it's Dagger, like a knife, DAGGR.
Okay.
So that's a new tool that I would highly recommend to check out.
Okay, thank you. Cristian, any opinion?
Not really, because as today we are using the old beloved Jenkins, so
We cannot say new.
No, some parts that are historically managed by Jenkins, we are writing something on our own, especially when it comes to the delivery part. We are writing something in Go and running stuff into Kubernetes as with the operator pattern, but it's not something tool that is well known and is emerging. So I would say we are still on the old Jenkins.
Okay. Another question. Maybe it can be. We can have the opinion by Cristian, because we had some information about this during the Piotr talk about certification, obviously. So to keep you up to date in the Kubernetes ecosystem, aside from passing certifications, but the material you provided and the documents are really useful to keep up to date, I think. But do you have any other recommendation other than you provided, or Cristian, do you have what is your personal approach to keep up to date with Kubernetes?
I think one key factor is automate upgrades. So whenever you use a public cloud, you go there, you just click upgrade, and more or less you find everything ready, given that your application are compatible. I think on premise, like we are, you have to automate all the upgrade process, because if you have to manage manually, you will always fall behind because you don't have time, it takes time, and so on. Another approach we adopted is to configure new clusters from scratch. So we don't upgrade, we just configure new clusters and we migrate workloads. So we have both worlds here, and we haven't yet decided where we want to go from now. So we have mixed feelings about both solutions.
Okay.
Right. So keeping up to date, right, other than just exercising within the clusters you mentioned, creating clusters from scratch. More broader, what I do personally, I have a bunch of newsletters I follow, newsletters from guys like Chris Short, or newsletters for Kubernetes itself, and I'm subscribed to a couple of podcasts. So this is how I'm staying up to date, meaning that I know what's happening in the industry, I know what trends are out there, and what I do in my spare time, if I find any, I like playing around with tools that I learn about. So if I hear something in a podcast that piques my interest, or read something in a blog, I would just spin up my cluster locally or remotely, as I showed during my talk, and just give it a try. And sometimes, if it's really interesting, I will write a blog about it. And that's also the way how I ensure that I personally stay up to date with new stuff.
Okay. We have another question for Piotr, mostly for the exam, because people are very interested in that, I guess. The audience wants to get this sesame. he apparently the person who asked this question was asked if he can generate documentations automatically. Will that be part of the exam, and what can you recommend for this?
I don't. What do you mean by generating documentation automatically? Can you elaborate a little bit?
I don't totally understand the question either, but that's why I thought you might have a more idea and what will be a part of the question.
Right. So you don't have to generate documentation during the exam. You typically have tasks regarding working with clusters or with Kubernetes resources. You have to generate Kubernetes YAML. Maybe this is what you mean. So yes, you have to create YAML. There are various ways to do it. A lot of this comes from copy pasting YAML from documentation, or you can also use kubectl commands to create a stub for YAML and then edit a file. But very often in the exam, you will already have YAML available within the folder. You just need to read questions carefully, and then you can go ahead and adjust this YAML. I'm not sure if this is what you mean by auto-generating documentation.
Either you think, yeah, documentations, or maybe he meant configuration files automatically. Okay. Also, another question for you about the exam. So how did you cope? You said the first time you actually had trouble managing your time efficiency. How did you cope with that, with other exams, and how did you improve?
Oh, I coped barely. So you basically, the best advice I can give is to practice until kubectl commands become really second nature. They are very fast, just comes out of your fingers. And I also talked briefly about a strategy that I employed where if I see that the question is highly weighted, so it has a high percentage weight and I can do it, I do it. One thing I want to say that specifically for me was a problem. When I'm stressed, I am reading really fast and skipping some of the parts. So I'm not fully understanding the question. This is really dangerous because questions are often a bit tricky. So although you want to be fast, you have to go slow to be faster. So take time to read a question really precisely. Make sure you understand it, and then go for it. So it's a little counterintuitive, but yeah, start from questions that are highly weighted and you understand how to do them. Go and execute it step by step. What costs a lot are mistakes. So what I did very often, I implemented very simple procedures to check whether what I did works or has been indeed deployed to the cluster. So I just had some heuristics internally that say, okay, I'm going to run now kubectl get pod and see if it's working or something like that. So I'm sure that it's actually worked. But right, it is basically practicing a lot, and then during the exam, reading questions carefully and prioritizing the questions that are highly weighted and you can do them, and leaving the simple ones at the end, because you will be tired towards the end. Your brain capacity will be gone, and if you leave hard questions towards the end, you're not gonna do them.
Okay. Maybe we have time for a last question before the end. This is originally a question for Piotr, but I want to make it a bit more generalized. Yeah, so the usage of Kubernetes and when to use container manager services, it can be for both Cristian and because I understand, Cristian, you're mostly on premise and you don't use public clouds. So either UCS or installing Kubernetes on servers. I think what are your use cases when to use Kubernetes, actually using microservices, and which either going for public clouds or going on-prem? Okay, Cristian, maybe you can start if you want.
Yeah. So when we decided to adopt Kubernetes, we had the opportunity to, let's say, install on our own or use some well-known distribution and setup like OpenShift, Rancher, and so on. And historically, our company wants to manage the know-how. So we want to dig and know the ins and outs of our platform infrastructure. So ACS It's rather simple to use. You don't have to know much, let's say, but configuring and running an enterprise-grade Kubernetes cluster that is installed and configured, you must know well enough the component, the platform, and this gives you the opportunity to fully use and configure and know well how to, you can stretch the limits. And so for me, even if it's very let's say it's hard to get there, it's better to use a bare metal Kubernetes and be installed on your own, because you have to learn a lot, but you will benefit a lot.
Yes, mostly everything is hidden when you use public cloud, whether it's GCP or Amazon or any kind. It's harder to understand what's happening behind, and if you have problems and you cannot understand and rely on the support of those providers, it's harder. But it's really time consuming to create your own bare metal Kubernetes cluster. That's why. Any thoughts, Piotr?
Right, so I definitely agree with the aspect of learning. We also run clusters on-prem, we use Rancher, and you need an in-house expertise to do that. But learning is great, but operational concerns and scaling becomes an issue if you have in-house capabilities. You're not really that elastic on-prem. If you know exactly your use case and you know that you need one cluster and you just maintain it like that, that's probably not a big problem. But if you have to start creating a lot of infrastructure and scale it, that becomes an issue if you're on-prem. For cloud specifically, there are various services that support containerization. So ECS was mentioned, but there are plenty more. And I guess this is more of an architectural concern. So you would basically start going for this low-level PaaS-like or rather high-level PaaS-like services at the beginning and see if this supports all your use cases and you have a little bit of room to grow. The moment when you start needing Kubernetes is really where you have to operate on a very high scale and you have to have a very detailed control over your workloads and your environment. Then it's becoming more of a Kubernetes question, because even cloud providers do not give you access to manage master nodes. You more or less have full access to manage worker nodes, create additional configuration on Kubernetes, install add-ons, and so on and so forth. So there's much higher degree of ops effort that you have to have, and not comparable to on-prem, but still you have much more power at your fingertips when you use Kubernetes. So there's this trade-off, obviously. If you feel that your microservices, let's say, infrastructure requires high elasticity and a lot of scaling, and you have complex requirements around networking or load balancing and stuff like that, and you want to control those things, yes, AKS or GKE or EKS in cloud providers become an obvious choice. But I would always start by trying to evaluate PaaS offerings, containerized PaaS offerings. Each cloud provider has them, and then move to Kubernetes when the team basically say, okay, we need this control.
Okay. Thank you. I think this will be the last question. So thank you for your participation for this summit. And thank you for answering the questions, and thank you for your presentations. And I hope we can see you in another summit another time.
Thank you. It was a pleasure. Enjoy your summit, everyone.
It was a pleasure for me too.
Thank you very much.
Goodbye.
Bye-bye.
So we have a short video about sponsor before our last speaker, and now.
And now we want to say a huge thank you to our sponsors at Prophecy. Prophecy Labs is an innovative cloud ops platform that helps customers gain control over their cloud infrastructure. Taking global cloud adoption will continue expanding. That will catalyze cloud spend and sprawl, and we already feel it. Given market's expectations for the adoption of fully managed cloud services is growing year after year, Prophecy Labs' experts designed a cloud ops platform to let the users visualize, govern, analyze, and optimize their cloud infrastructure. Powered by artificial intelligence, Prophecy Labs analyzes system usage and user behavior patterns and provides unique insights to help cut cloud costs and stay within the cloud budget that you have. The platform helps young startups to survive on the cloud. However, it will be equally helpful to large enterprises also, where every business's new project is kind of startup also, and where not only managers, but also DevOps engineers responsible for the budget. And only today, by the link that we will post now in the chat, you will get 1 year of free usage of their awesome platform. Thank you, Prophecy.
Thank you, Pavel. So talking about Prophecy, our next speaker is Anton Grishko from Ukraine, and he's going to talk to us about how to make your cloud match your needs. So just to make a quick introduction before putting Anton, he has more than 10 years of experience in building complex infrastructure and automating development processes. Anton leads professional tech experts to design and develop cost-effective and high-performing cloud solutions, bringing the best DevOps practice and methodologies to the table. So let's see with Anton. Hello, Anton.
Hello, hello. How are you doing today?
I'm great, and you?
Good, thank you.
Still
Nice
snowy in Ukraine? It's still snowing in Ukraine?
Yeah, it's still snowing and it's freezing today.
Okay. So Anton, I will give you your time to talk, and I'll see you after. Thank you.
Yeah, thank you so much. Okay, so first of all, thank you so much for introduction and thank you for having me here. This is my LinkedIn. If you would like to, if someone would like to add me to your network, welcome. I'm always welcome for new connections. About myself, really quickly, I'm chief architect at Prophecy. Before that was a DevOps architect. Before that was a cloud architect. Also was a head of DevOps. I have a huge experience working with different clouds, different teams, and different companies. And here at Prophecy, I'm trying to bring the FinOps into the table and trying to help our customers to make their cloud as cost efficient as possible. About ourselves, about our company, we are Israeli DevOps boutique company. Means that we are providing DevOps as a services to our customers, and as a part of this involvement, we thought that there is a huge need for cloud cost optimization for our customers. As a result, we started to thinking about how to help our customers to achieve their cloud cost optimization. And today I want to introduce to you a very nice project that we built. It's called the Prophecy Labs, and we will talk about FinOps today, and we will talk about this product. I will show you a quick demo and we'll answer on your questions. So let's begin. First of all, what's the FinOps, which is the financial operations? You need to know that a couple of years ago, actually 2 years ago, the FinOps.org was created, which is the FinOps Foundation. It's a non-profit organization that's trying to establish principles, establish a FinOps role, and FinOps goals. You can visit the FinOps.org website to read more about the FinOps Foundation organization and about what the FinOps is. And I actually borrowed from their website a very beautiful and short explanation of what FinOps is and what are the principles of FinOps. So what's FinOps? All of you remember that before the clouds, we had the on-prem and co-locations, and the process of getting the new hardware was pretty much straightforward. You need to add more service to your data center. You actually go into financial organization, to your fin guys, and they're doing the procurement for you. You basically saying what do you want to get. They're trying to get the best price, and once they found who's going to give you the hardware, they're paying for it, and the process was very it was very long. It was taking a long amount of time in order to get the new hardware to your website. And of course, that model wasn't ideal. It was very complicated to grow in that model, and a lot of companies had issues with not enough space, or and they need to move to another data center, or they need to add more servers, and so on. But the process of procurement was working perfectly. There was no issues with that. There was a financial organization which was handling all the financial aspect of the business, and they knew who and which team, what amount of service, what kind of service they own. So they knew who owns what kind of resources. Then the clouds came up, and we all started to work with the clouds. And I, as a DevOps engineer, was very happy leveraging all the beauty of the clouds, was creating and deleting the resources there. Well, what's wrong with that? With the clouds is that the procurement process is broken. It means that any DevOps engineer can basically request a resource, he will get it. Then guys forgetting to delete the resources, those resources spending money, and the issue was that business doesn't know the what amount of money they're spending, who is spending, what can be decreased, and so on. As a result of that need, the FinOps processes were introduced. And the principles of the FinOps is basically the teams need to collaborate, the DevOps team need to collaborate with the financial organization, with the Fin guys. The FinOps is not about the cloud cost optimization. FinOps is about buying what you need. It's basically about paying only for the things that you need. It doesn't mean that you need to buy the cheapest things. It just means that you need to choose carefully, and you need to think about future. You need to think about your cloud cost spendings. Yep. So in general, what the FinOps says is that each company should have an organization or engineer within the company which will be responsible for resources, for actually buying the resources, for tracking the resources. The main phases of FinOps is inform, which is the visibility of your resources, which is inform about the pricing. Optimize, which is to optimize your resources. And the third one is the operate, means that to track your resources, track the cost on your resources, and so on. So quickly, this is the FinOps. Nothing very special. It's the methodology, having the dedicated engineer or role within your company who will be responsible for looking for cloud costs, for your resources, and will be helping you to optimize all of that. Now, the next one, what I want to talk about is the trends. I found this graph. It's FinOps jobs trends in UK. As you see, in 2019, there was no FinOps jobs at all in UK, and then it started to pop up, and it's growing. So we are all seeing the new market. It's a new market that's growing on our eyes. It was the same story about DevOps engineers, when there was no DevOps engineers at all, and then it started to pop up. Same thing is happening for FinOps. There was no vacancies, jobs for FinOps, and now you have tons of them, and it's growing. It's going to be bigger and bigger from each year. So I'm just saying that the trend is clear. We're going to FinOps, and more companies will be willing to get the FinOps. You probably also thinking that, okay, cloud cost is always about the automation. We can simply automate everything, and it will help us to optimize the cloud cost. which is true from one side. But based on this graph, if you will take a look on it, you see that almost half of the companies are not doesn't have the automation at all. No automation at all. They're only moving there. It means that, as I said to you, half of the companies has no automation at all. So automation is a big thing in the future, but it will take a lot of time for companies to automate whatever they have, while they're already spending a tons of money on their clouds. And I want to introduce you our product. Let me give you a very short story before we'll show it to you. We here at Prophecy, almost all of us are DevOps engineers, and we're helping our customers to automate whatever we can and configure whatever we can, and actually make everything cloud cost effective. And a lot of our customers started to ask us to do the cloud cost optimization for them. And a year ago, we were doing it manually. We had an Excel file where you need to specify all of your resources. Then you take a look on the pricing on those resources. Then you build in the charts and graphs and trying to understand what you can do with those resources. Can you decrease them? Can you change the type of your instances? Or maybe you can change the whole architecture, and so on, so on, so on. And then we saw that, okay, it's very painful and very slow to work like that, to collect all the resources that customer has to the Excel and do the analysis of that. And we decided to write a couple of the scripts which will help us to achieve that. And then those scripts become a tool, then tool become a portal, and then a portal become a startup. And now we have a startup that help us to do the cloud cost optimization for our customers. And we are willing to share this product with all of the DevOps engineers around the globe, free of charge. We want DevOps engineers and managers to basically help to achieve the cloud cost optimization as much as possible. So let me introduce our product, which is called the Prophecy Labs. It's an AI-based multi-cloud platform. Why multi-cloud? Because we are capable to connect the AWS at the moment, and GCP is already in alpha. We're also going to add the Azure really soon. And our tool is helping to take a look on the cost, not only on one cloud, but on all clouds together, and also on the different accounts together. For example, you could have a couple of AWS accounts, you can connect all of them together, and you can take a look on what's the cost of your resources, what amount of your resources, and so on. In our product, we decided to concentrate on 4 areas. As you will see, our product is not only about the FinOps, it's basically helping to everyone, to FinOps, DevOps. It's doing more than just the cloud cost. So we decided to take our attention on 4 different areas. First area, which is the FinOps, to do the to analyze, manage, and do the optimization of our cloud costs, and also DevOps, to basically take a look on how many resources do we have, what kind of resources do we have, details about those resources, and so on. DevSecOps, we embedded the security tests in our portal, and doing the security vulnerability tests for your infrastructure, checking like security groups, checking that MFA is enabled, and so on. I will go deep in that a little bit later. And we concentrated on visualization, means that we are giving good visualization about your infrastructure. We are generating the AWS, for example, for AWS, we're generating the diagrams with the resources, the network diagrams with the network flow, and so on. Next, cost management strategy. So we, in terms of cloud cost optimization at Prophecy Labs, we saw a couple of the opportunities. First of all, is the right sizing. Our machine learning algorithm is basically checking the current size of your resources and trying to understand if that size is good or not. If it's like too big, our platform is giving the recommendations on what different type can be used in order to achieve the cloud cost optimization. I will show you during the demo how it looks like. Also, in our product, we have the intelligent scheduled spots. It's again machine learning algorithm that's trying to see the pattern when your spots are gone and trying to minimize this downtime. As well as we are capable, again using our smart scheduling and our machine learning models, to work with the stateful and stateless spots. By the way, it's pending the patent. It's our patent because it's our development. This smart scheduling and smart spotting is our own development and it's waiting for patent. Also, we're giving the detailed cost analysis, showing what kind of resources are spending money. Waste management is one of our features, which showing you totally wasted money, for example, unused volume or unused IP address or some unused VPC. This is something that Waste Manager, our feature, will show. We also doing the reserved instances and savings plans when our platform is giving the recommendations about the reserved instances and savings plans and helping you to save a lot of money for that. Moving next, Cloud List, Cloud Map, Cloud Net. This is our features. We'll show it during the demo. It's showing the resources, details about resources. It's also generating you the cloud map, the diagram with all of your infrastructure, and the Cloud Net is generating the diagram, but from the networking perspective, showing how the traffic is flowing into your infrastructure. As I mentioned to you, we are using machine learning based algorithms behind the scenes, and we're trying to leverage machine learning as much as we could. For example, we're using the ML for spot pricing monitoring. The ML is monitoring the spot price and helps to make a bid. And smart scheduling as well. We are providing the recommendations when the machine or resource is actually used, when not. I will show it to you during the demo. Now the demo time. Let me share my screen just a second. Okay, beautiful. I hope you see it. So this is the prophecylabs.com. This is our product. It's a AI-based new cloud management platform. I already logged in, going there. First of all, what I see the dashboard. On the dashboard, I see that I have multiple accounts already here. I can choose a couple of the accounts together. It will show me a summary of all of them, or I can go one by one. I see the dashboard. On the dashboard, I see the map of my regions and availability zones where my infrastructure is actually located. I see that some of them are red. It means that not all of the resources are used. There are some of the resources that are unused, and we can click on it. We can go deep inside, and we can take a look what are those resources that are not used. On the right side, we see the billing summary. So I see the current amount of money spent by this account. Also, we are showing the credits. This is the AWS account, by the way. We are showing the credits, something that AWS doesn't show. We're showing the credits and how much of them are spent. We are showing the savings, like how much you already saved, how much you could save if you will perform all the suggestions. Which I mentioned.
Hey Anton, something happened with your mic. Can you please double check? Disconnected, I guess. Can you please replug or double check because it's not working at all?
I was muted. I see. I was muted. Can you hear me?
Yes,
yes, we can.
Now?
We can. Yes.
Yes, super. Sorry. I was muted. When I shared my screen, it actually became muted. So, right sizing, really quickly. For example, we have this EC2 instance, which is the POC Postgres instance. Our platform is saying that it's currently used on 20%, means of the resources, CPU and memory utilization. The type of this machine is M5 2x large. And our platform is saying that change it to M5x large, make it 2 times less bigger. The usage will become 40%, but you will start saving $86 per month. And you basically can apply right from here. You can click on modify, you can click apply. That's it. If you don't want to use this type, you can expand the list, you can choose different option, and again, you can apply. Same for reservation. We have reservation suggestions. You can simply apply the suggestions, and for example, the RDS will become the reserved instance, and you will start paying less. Also, we have a feature which is called the Cloud Sitter. Cloud Sitter helps you to shut down the machines per schedule, per policy. I will give you again the example. So you see there is the running and sleeping machine, so I can start stop machines from here. Not only machines, also the databases, the Kubernetes clusters, the auto-scaling groups, the Redshift. A lot of services are supported. And I can create the policies, like I can create a policy, for example, night sleep, shut down the resources during the night, and then they will be working only during the day. So I can create as many policies as I want. And also a feature, we have a feature which is called the spot. I will show you just an example of one machine. For example, we have this machine which is called the training test. It's quite a huge machine. The on-demand cost was $17,000 per month, and when we spotted it, it basically currently costs only $7,000, and it saving $10K per month for our customer. Yeah, and the last but not least, which I mentioned to you, you can take a look on all of your resources within your account. You can click on details. You can take a look on the details of the resource. This is the NLB. You can take a look what ports are listening and so on. And you can even click on a cloud map. It will generate you the map of your resources. Everything is clickable. For example, we have this volume. I see the price of volume, and I can remove the volume even from here if I see that this volume is not used. Probably that's it. And CloudNet. Also, I mentioned it to you during the presentation that we are generating the map, the network map based on the resources. And again, you can take a look on all the details about it. Now, let me get back to the presentation. Yeah. So the takeaways from here is very simple. Our platform is built by DevOps engineers for DevOps engineers and anyone who wants to save some money on your clouds. Currently, we do support AWS, and GCP is going to be released for public really soon. The next one will be Azure. We are fast-growing young startup built by DevOps engineers for DevOps engineers. Thank you. Questions, comments?
Thank you, Anton. I have a question. We don't have much time, so but I have a personal question. Okay, for me, FinOps is still not completely matured since a new concept as DevOps was in the past, and it gathers a lot broad spectrum of skills in DevOps, in finance, in cloud, in data science, in programming and security, etc. How do you manage your organization, and how do people communicate with each other? How did you manage to build your team? And which of those skills you think are the most important?
No, very good question. Thank you so much. It's actually true. It's fast and growing, young, new thing, the new market, and of course, at the moment, it's not clear what skills are more better or more important for engineers. But I will give you some of the tips based on my experience. At the moment, basically, we are converting our DevOps engineers to FinOps engineers. So let's say we have a team of 5 engineers, and one of the DevOps within the team will be dedicated for FinOps work. It's one of the patterns to do. Basically, DevOps who is familiar with the infrastructure, familiar with the cloud, familiar with the pricing, will be dedicated for this role. Another thing that we are trying is basically engineer from the financial field, so not from the cloud field or from DevOps field. The engineer from the financial field, we are teaching him a cloud, him or her. We're teaching a cloud. We are teaching what are resources, what kind of things you should take a look on, and then this engineer is basically using our tools. So and other tools, you're probably familiar that there are a lot of different tools for FinOps available at the moment, and this engineer is basically taking care for FinOps. And this is our idea. Our idea is that the people with the financial background or economics background, they actually do that. They're capable to do the FinOps, especially if they will have a proper tools, easy to use tools, not something that you need to know how to code or how to script.
Okay, thank you for the clarification. I think it was a really important question. So thank you for your presentation, Anton, and your participation. And
you're welcome.
I wish you a good day, and thank you. So I wish everybody a good day too, and it's time for a small break of 10 minutes and maybe an announcement, and the next moderator will take my place. Goodbye.
And now we want to say a huge thank you to our sponsors, PhoenixNAV. PhoenixNAV is a global IaaS provider offering colocation cloud and dedicated server deployment across the globe. Deploy their bare metal cloud service in minutes and get 15 terabytes of bandwidth for free. And you can get this deal through the link that we will post now in the chat. You can learn more via this link. Thank you, PhoenixNAV. Welcome back, everyone. And now we want to say thank you to our sponsor, Site 24/7 by Zoho. Site 24/7 is a full stack performance monitoring tool. and it will help DevOps engineers and IT operators to monitor websites, apps, services, cloud, and network. And this is a part of Zoho Corporation. And today, if you follow the link that we will post in the chat, you will receive access to $250 value of services at site 24/7. It will be added to your account, and you will be able to use it around 6 months. That's what it's worth to do the monitoring of websites, synthetic web transactions, and lots of great stuff. You can read more in the description, in the chat, and also you can click this link and you will receive this credit to your 24/7 site account. Thank you, Zoho, once again.
Hey folks, Nick here. I hope you hear me well. So our next moderator, Rui Rodriguez, is connecting now, and just gonna fill in for him. I'm gonna announce. Oh yeah, here it is. Hi, Rui.
Hi, Nick. How are you?
I am fine. Like I just gotta announce our next sessions. Can you turn on your camera?
Okay, I'm trying to turn on the camera. Just a second. It is. Turn it on.
Oh, well, just really like try to do whatever you can with your camera. I'm just gonna read the next speakers. We have 2 speakers from Microsoft. It's Jorge, Valenzuela, and Ignacio, Melero, Miguel, and they're gonna tell about GitOps. Wake up! It's not a dream. There are your new IT ops. I'm gonna add them here to the stage. Hi, folks.
Hello, Nick.
Hello, Nick.
Yeah,
how are you doing?
Yeah, I hope Rui will connect his camera in a moment, but just gonna leave the stage to you. Here are your slides, and good luck.
Okay. Thank you, and thank you to all the Geekle organization for this invitation and for the amazing event. Hello, everybody. My name is Ignacio Melero. I am one of the Azure developer technical leads in Microsoft, and with me, Jorge Valenzuela, Cloud Solution Architect Manager of Azure in Microsoft too. And today we are going to talk about GitOps. And as you can see in the title, wake up, guys. This is not a dream, and these are your new IT operations. And we are going to see what is GitOps and why it's very important for all, not all the companies, but also startups. Hello, Rui. You want to say something or not?
Hi there. I'm sorry to bother you. Please continue.
No worries. Okay, so, but today I am not Ignacio from Microsoft. I am Ignacio from Closet. Closet is a very new company about NFTs. It's not related with OpenSea. And today I bring to my offices to Jorge, very famous cloud solution architect from Microsoft, because I have some questions for him about all these new trends of GitOps. So Jorge, thank you for coming to my offices, because I need to discuss with you a few things. As you already know, like more or less 5 months ago, I built my own company. Sorry, I am not an expert on PowerPoint, as you can see, so I don't know why the slide is not complete, but anyway, let's continue with this one. As you know, I am a fan of the startups and the way of how they develop applications and how they build things on cloud. So when I started my own startup, Closet, a few months ago, I called you because I want the best advice from Microsoft in how to do things in the cloud. And you sent me these 5 pillars to become cloud native. And I have tried to follow one by one. And the first thing that, of course, I do is to adopt a culture of DevOps in my teams of developers. As you know, I have data scientists, developers. I have, Java developers and different teams. And one of the things that I want is that all work together and they leverage the work of the other teams. And they, of course, work with the operations teams as well, because everything is going to be deployed on cloud. But not only on Azure, as you know, we are not only working with Microsoft, but we are working with other providers as well. And we have 13 workloads also on premise, as all the companies. As you know, we are a startup, but we want to secure 13 workloads on prem because of 13, security issues. So the first thing that we adopt is DevOps, but after that, of course, we move into containers and we try to develop everything following a microservices architecture because we want to be very scalable in cloud. And as you know, we are an e-commerce marketplace of NFTs. And NFT is a real trending topic right now, and everybody's talking about this, and everybody wants to buy NFTs. So as you can imagine, my website sometimes gets huge traffic of people, and I can't, have issues when you are navigating my website. So one of the main things that they need is to use Kubernetes to have, rapid scalability when I have a lot of traffic on my website. And we use different open source tools like virtual kubelets to scale in seconds our containers and things like that. So yeah, we are using microservices, we are using containers, we are using Kubernetes to orchestrate everything. And of course, in terms of application, we are using 13 technologies to manage all the APIs that we have for our customers, but also 13 serverless services, to be more efficient and just to focus on the applications because, I have a very huge team of developers and I want them to focus just on the apps and not on the infrastructure, as you can imagine, because I want to reduce the time to market, being very lean, add new features to my website, and I want to do this very fast just to try the features. And if they doesn't work, just come back and try another thing. So this is my main idea with my startup, with Closet-C. And when I adopt all these technologies, you told me that if I don't do this adoption of cloud native, I am missing a lot of opportunities in terms of productivity because I'm going to waste a lot of hours in develop and in deploy to the infrastructure. And if I want to create a new project and I am not leveraging the work of the other teams, I am wasting a lot of time of my developers. So DevOps, of course, solved me this. Also in terms of money, as you can imagine, because my developers are using different technologies like code spaces to develop in web, and I am not caring a lot about the local device. I am more caring about the libraries and the different stuff that they need to do to deploy the application. Of course, security, because I am saying DevOps, but we are adopting DevSecOps as too, because we introduce, different security tools in the pipeline, and during the deployment of our applications, we are analyzing the code, analyzing the libraries, the dependencies, and everything. So it's good. And of course, collaboration and talent. I am very fan of this because if you don't have the best tools, your developers don't want to work with you. So I need to combine them with the best, tools and the best environment for them. But the other day, one guy comes to my offices. It's another CTO of another startup, and he told me, "Hey, Ignacio, you are doing a lot of things related to cloud native, and it's nice, but you are not taking care about the deployment of your infrastructure." And I answer him, "Well, I am doing infrastructure as code, and you told me that, Jorge, that this is what I have to do. But it's true that my infrastructure as code, we have the templates, the operations teams have the templates, and they update them manually, and after they deploy it and everything." And this guy starts to talk about GitOps. You need to introduce GitOps in the culture of your organization. And I start to ask him about GitOps. He told me that GitOps is more like a set of tools more than a culture, and it's like an evolution of DevOps. But being honest, he says like 1,000 teams GitOps, but I don't understand what he's talking about. So I need to understand a little bit more why and what is the difference between DevOps and GitOps, because I guess that is something else than versioning the infrastructure as code. Is more than that. So that's the reason that I bring you here, Jorge, because I want a clear explanation from Microsoft about this. What is your advice in terms of what kind of tools I can use to adopt GitOps, and what I can do in a multi-cloud strategy? Because as you know, I need something to govern everything, and I certain issues in terms of infrastructure and observe and maintain my infra in the different places, in the different clouds or on-prem, and I have to govern everything from the same point. So Jorge, please give me some answers to these questions if you can.
Okay, sure, Ignacio. First of all, I'm glad that the journey that you took when I was here last year about talking about you and your startup for adopting cloud native technologies and so on. And I will say that it's a good question about what's the difference between DevOps and GitOps. Okay, because DevOps is more like a cultural change for the developers, and it's a way of bringing value to your customer more frequently. Okay, so you need to be able to deliver value to your customer as soon as possible. So having all the people doing that and taking into account that they are working for delivering value is key. Okay, but that's more on the way of they are developing. But GitOps instead is more focused on how you are performing those changes in your infrastructure, in your application, etc. every day, so you can really avoid errors, reduce the time to deploy, have better observability, better availability. So it's a lot of things. Okay, and sometimes it's not a big barrier between both. One is the complement of the other. So basically, as you were explaining, you are having a big journey in your startup, and I'm really happy that you are getting that success. So that's great with the NFTs. And probably you are now facing the issues that you are growing, you have a lot of infrastructure to work with, you also have a different technology stack, you have some languages for one part of your application or your microservices, you have another one for others, and probably you are also running your infrastructure in different providers. Even you can have your private cloud, you can have your multi-cloud strategy, or whatever is your strategy, okay, to maximize the availability of your application. So in terms of how do you manage all that complexity in a big heterogeneous environment is not easy at all. So you need to ask yourself questions about how can I make automation as a standard for deploying in everywhere. So not just a different automation artifacts for one cloud or for another. Or do I have any graphical interface where I can see the status of in your cases, the status of your Kubernetes cluster, because you are running on containers. But imagine that you are a legacy enterprise with running, or not legacy, but having a lot of servers where you are running your operations. You need a place to see that in a single pane of glass. Okay, so that's also a way to facilitate your operations. You also need a centralized way to have billing or charge back to other business units in your company. You need to ensure that when someone is bringing up a container or is bringing up a virtual machine, they are in compliance with your security standard. So they are not using or opening ports that they don't need to open. They are not using any operating system that is not up to date. This kind of thing. Okay.
Okay.
And GitOps is not only
That's the question. What is GitOps?
Okay, so I'm going to focus on your specific use case, because GitOps is really, or was born for cloud native services. Okay, but it doesn't mean that you cannot apply for your servers or for your legacy infrastructure. You can use GitOps as a way of working for every service that can provide you observability, and you can modify it in a programmatic way. So that's all you need. So GitOps basically is using a Git repository as the only source of truth for every change that you are doing. It is not just for application, it is also just for your infrastructure. So every change should come from a Git repository where there are the files that you need to apply for making those changes. It's a change of paradigm. Instead of, or we are used to work in a push-based model where you create some file and you go to your cluster and you push the file in your cluster and you apply that configuration. Instead of that, the new way of working is your developers make a change in a file, which is in Git, in our Git repository. They change the desired state of the infrastructure in that file, and there are some artifacts in your cluster or in your infrastructure that are making or are pulling the status of those files. And anytime that there is a change, they pull the information and make the change, calculate the change that they need to do to ensure that they are in the desired state that you are defining in those files. So basically, that's the head of GitOps, is defining your desired state using as a source of truth a Git repository. Okay, so it has some benefits. It is not. It has some, or it is not so easy as it sounds. So you need to change your way of working, and it's also a mindset change that you need to do in your teams. But it also gives you some great advantage that work, that are worth it. So for example, you have a single place where you are putting all the changes. So in terms of traceability, in terms of tracking who was performing this task, who was the chain, or what was the chain that was done, and why this is failing, and tracking the commits in the Git repository is easier than if someone is going to your cluster or making a change. So you also have an easy way of making rollbacks. You also have a more controlled way to deploy in different environments like staging, production, or pre-production. So for you that you are running a great startup that is growing quite fast and you have users coming from all over the world, I cannot imagine how you can work without GitOps, because you have 1,000 of cluster work running, and I guess that having or knowing what's the real status at one point in time is quite difficult.
So summarizing, I'm getting the benefits of DevOps when you are developing an application, but you are doing the same with your infrastructure, with everything around. You know, you are including the infrastructure in the integration and deployment pipeline, and you are guaranteeing the desired state of the infrastructure. You can version it, you can have rollbacks. You are doing the same that you are doing with an application, but with all the infra of your world. So it's
indeed. You make a great summary. Exactly. Yeah.
Okay, understood. And what about the flags? You know, because what is the workflow to do this, and even more, if you can show me a demo about this.
Sure, I will show you in a few minutes how it works and how from Azure you can use GitOps in your environment that you are using right now, or standardizing your applications running over Kubernetes. But the main thing is that you need to use an agent or an artifact that is the one that is in charge of looking at the Git repository that you are configuring as a source of truth. You need to have that in place, and also you need to define what are your delivery strategies. So for example, you can configure something like every time that there is a new push in my branch or in my master branch, I want that it automatically deployed to all my dev cluster, for example. Okay, so that's something that you need to also decide. But other than that, it's quite easy. So it's not so complex. So I will show you now that I'm going to share my screen, and please please ask any question that you could have.
As you know, I prefer the demos than the PowerPoint presentation, as you can show before.
Yes, sure. Let's go for it. Just sharing my screen. Just one moment. Okay, there we go. Okay, you are seeing my screen now, Ignacio?
Yeah. Yes.
Perfect. So, Ignacio, as I was mentioning to you, so first of all, we need to put that artifact in our Kubernetes cluster. In the case of Azure, we are really, we are working really hard on being the single control plane for all your Kubernetes clusters. We don't care where they are running. So you can have some cluster running on Azure, you can have some cluster running on AWS, you can have some cluster running on-prem. As long as they are Kubernetes compatible with the CNCF specification, you can bring them to Azure and start using them, integrated with GitOps and so on. So I'm going to show you that as a first step, okay? How to onboard those Kubernetes clusters as a first step to go to the GitOps operations.
Okay, sounds good.
So first of all, I'm here in my Azure portal, okay, as you know about it. And here, well, I am trying to create the illusion that we are running a Kubernetes cluster out of Azure. So please, I created a couple of clusters. One of them is the Dev cluster and the other one is Prod cluster, as you can see here. They are running on Azure, but I'm going to add it to Azure Arc. Azure Arc is our control plane for hybrid operations. So what I'm going to do is use these clusters as if they were running in any other place. I don't care, okay, because I will use kubectl for connecting to Azure, and then I will bring them to Azure like Kubernetes Azure Arc cluster. So, well, first of all, the way to do that is not so complicated. So you can go here to your Cloud Cell, and it's just you just need to know or to be sure that you are connected to the cluster that you want to connect to Azure. Okay, so if I run kubectl get node or get ns, I'm going to know that it is a new cluster because it shouldn't have anything. Okay, they have these 4 namespace, nothing new. Okay, it's a new cluster that I create just a couple of hours ago. So basically, I want to bring it to Azure. So let me put the command line here. Just one moment, please. Basically, how can I bring to Azure any cluster? Is something as easy as this. AC, connect, the name of the cluster that I want to see in Azure, okay, and what is the resource group where I want to onboard this cluster. That's all. Okay. And as long as kubectl is pointing to that cluster, it will install everything. So nothing else, okay?
You have the cluster on Google, AWS, or on-prem, and you are connecting directly via your cell of Azure, but you are going to manage the different clusters from the same point, even if they are running there. So you can operate them from this single point.
Exactly, that's the beauty. Okay. So this just one command, and you start getting your clustering on Azure. Once you have your clustering on Azure, you can get monitoring, you can get observability, you can ingest logs, and you can manage all the operation from Azure, okay? Even the compliance, you can configure security, you can configure or even enforce security policies, RBAC, whatever you want, okay? So that's the first step to embrace the GitOps mindset. So while it is running and onboarding on Azure, okay, that it takes like 5-6 minutes because it deploys a lot of artifacts in the cluster. I have here another, well, it is starting to be here, as you can see. Okay, so now it is on Azure, and from here you are starting to see the version of Kubernetes, what is the agent that was installed, and well, everything that you need to
it's not on Azure, but you can manage
exactly it. It's like a projection on Azure, and you can exactly work with this cluster, and it's just one command to onboard it, and you can start operating over this cluster.
Okay, cool.
So now I have a cluster, and you have a lot of options here, as I was mentioned, like I can configure the storage, the namespace, the workload, whatever. I have here another cluster that is this one. Okay, go back to here, the Dev cluster, and I want to deploy a configuration. So this is a good example. If you want to start looking at what GitOps is, I recommend you to go to this repo, because this repo contains a very good examples about how to work. Okay. So first of all, we use Flux version 2. Flux version 2 is the artifact that makes GitOps a reality in our cluster. So Flux is the agent that is running and pulling the changes from the Git repository to apply the desired state in the cluster. But also we rely on customize. So we use customize to avoid having to create templates for every application. So we can have a same standard base for all our deployments, and just to customize the specific for development, production, and so on. Okay, so if you can see here and you go deeper in this repo, you will see that it has this kind of a structure where you can define what are your configuration for production, what is your infrastructure that you are going to create in your cluster, depending also the cluster that you are using, if you are deploying to production or to staging. So everything is in a repo. Okay, so all your developers or all your architects that are working on this will have to make their changes in the repo, not directly into the cluster. Okay, and now that you have this, applying a configuration is also quite easy. I will put the command line that we are going to use, okay, and I will explain what are the parameters and so on. So just give me 1 sec, and let's go to apply this configuration that I have in this repo. Okay, so I'm not connecting to the cluster, so I am just using the AC. Let me go back to here. Okay, I'm going to use the AC CLI to deploy a configuration. So I am not connecting to the cluster anymore. So I'm not touching the cluster itself. I am configuring this from Azure. So if I want to apply a policy for my user or for your developers and so on, you can avoid people creating configuration. You can lock that anyone is touching your cluster, so you can apply anything that you want. So basically, this is the command line. So we use AC. We put here the sub command. We use Flux as the artifact I was mentioning. We create a new connection with the repo. We specify the resource group. We specify how we want to, this is the name of the cluster. This is the name that we are going to give to this configuration, to this specific configuration. We also specify what are the namespace where I want this repo to be deployed or this configuration to be deployed. Okay, I use -t connected clusters is one of the types that Azure Arc supports. We can also have a cluster that are not connected all the time to Azure. Imagine that you are running some cluster in a disconnected area, so we can also do that. Okay, and we can even also work with a proxy or whatever. Now we define the scope. So in this case, we use the scope cluster because we want to make change not just at a namespace space, but also in a cluster because we want to create services, we want to create IP, we want to create a load balance, and so on. We give the URL of our repo. We also specify the branch that we want to use. We also specify the customization path. Here I can use, for example, I don't know, let me check here in the name apps, I can use staging, prod, or whatever in this specific parameter. Okay, so I can change that. And also that the customized templates are not deployed until the part called infra is deployed. Okay, so I can put a dependency because it will fail other case. And that's all. You just go, yes, give me a moment. Apply this, and it will also install Flux in your cluster. You don't even need to install anything. It will do it automatically. So you just need to have your people writing in your Git repo, and that's all. And this is what we call GitOps for Kubernetes cluster.
Okay, cool, Jorge. So I think it's crystal clear for me. I need to try it. I'm going to use the GitHub repo that you have shared with us. And I'm going to try this and start to loop into the DevOps practices of my IT operators in order to introduce this kind of guarantee that my infrastructure is always at Sulby, and try to reduce efforts and time in the deployment of the infra. So thank you, Jorge, for coming, and thank you everybody for coming here and joining us in this session. I hope you enjoy the rest of the event.
Okay, thank you very much.
Thanks to you,
thank you, both of you, for your great talk. And we will have a short announcement after your talk. Again, thank you very much, Ignacio and Jorge. Great talk.
Thank you, Rick.
Thanks to you.
The urgent push to go digital is accelerating the shift to cloud, using containers and Kubernetes to speed the pace of application delivery. But securing and operating these apps is difficult, as legacy security tools can't see inside containers. For cloud teams already running in production, one fact is clear: seeing is securing. Cloud teams need to integrate visibility and security into their workflow. DevOps is not enough. It's time for Secure DevOps. Sysdig provides visibility and security to confidently run containers, Kubernetes, and cloud. With Sysdig's Secure DevOps platform, cloud teams can secure the build by flagging vulnerabilities and configuration issues, detect runtime threats, and respond using a detailed activity record, and continuously validate compliance. Sysdig is a SaaS platform built on an open source stack to accelerate innovation, enhance usability, and drive standardization. Sysdig's Secure DevOps platform provides visibility to run Kubernetes, containers, and cloud with confidence. Make your move to Secure DevOps with Sysdig.
Hi, people. Great talk, isn't it? So I'm sorry about the technical issues on the start of the block. I'm Rui Rodrigues from São Paulo, Brazil, and I'll be with you as a moderator in the second block of talks. I work as a responsible for the technical QA core on entity data, and it's a great pleasure and an honor to be here with you. So I want to introduce you to our following speaker with no more delays. His name is David Jambor. She's from Vodafone, UK. He's the head of systems engineering at Vodafone, and he will talk with us about the stages of DevOps. I think that it's going to be a great talk too. David, are you here?
Hey guys, very good afternoon. Yes, I can hear you. Thank you very much for having me.
I think you're, yeah. Now
I can hear you. Can you hear me?
Yes, I can hear you.
Awesome.
David, the stage is yours.
Thank you
very much.
Thank you. Once again, much appreciated to inviting me over and giving me the opportunity to talk. Let me try to share my screen to share a screen, share, and could you please confirm, can you see my screen? Awesome. So once again, very good afternoon to everybody. My name is David Jambor. I am the head of systems engineering here in Vodafone UK, and I'm here to talk about Vodafone's revolution with SRE, or the stages of DevOps. So basically, let me give you a little bit of context of my current role and what I'm planning to cover. So within Vodafone, we have a layer called DXL, which stands for Digital Experience Layer. And that's basically consists of all the means you as a customer could communicate with Vodafone. If you go to the vodafone.co.uk website, if you use your My Vodafone application, if you use Toby, Voxy, or any other means through the internet, then you're very likely going to communicate or utilize a service which is hosted by my team. Now that you have a bit of context, basically, we're here to talk about DevOps and talk about SRE. So if we go back in time about 20 to 25 years, you remember very likely this old challenge where you have an independent entity called our development team, and that you have another independent entity called your operation team. And there is many companies today who operate in the same way as they did 15, 20, 25 years ago. So the challenge, or actually the clear objective of a development team, is to produce new features, produce as many and as quick as humanly possible, to make sure that they deliver value for the business, for the customers, for the company. Now, the operation team have a different mission, which is keep production environment stable. If we would use, if we would compare these two objectives, you would very easily able to see that there are going to be challenges between those. So how operation is usually achieving environment stability is by setting up processes and controls before allow any deployment or changes into the production. Stability is achieved by reducing the number of changes. So it's basically the philosophy of if you don't touch it, you can't break it. Now, the problem is development teams want to touch it and want to go as fast as they can, but it means lots of changes. And that introduced originally the traditional dev versus ops culture. And this is how the whole discussion started. Now, Google's response for that was, that's an interesting problem. How should we solve it? So they created, about 19 years ago, I think, the engineering discipline called SRE, Site Reliability Engineering. And they defined it saying class SRE implements DevOps. And they come up with all kind of nice framework and cultural things about this, which I would like to dive a bit deeper before I get back to this slide again. So what is SRE? And if I use Ben Trainor's words, when he created this function at the time, he was the vice president of the engineering team. He said that SRE is what happens when you ask a software engineer to design an operational function. Now, this is a really good way to summarize and say that, hey, if I ask my software engineers who are creating the code to also focus on the operational aspects of it, how would they do it? Now, really would like to differentiate between DevOps and SRE a little bit. DevOps is a wider range of philosophy, and that means that the DevOps culture allows you to follow a set of framework which would then help bring all of these teams together, would help the running the operational and the software development cycle much cleaner. However, the SRE engineering arm is trying to focus on more and more on the service-oriented, end-user-oriented outcome of the business. As a result, SREs have a much cleaner objective. Meanwhile, DevOps is defined as a set of culture which is possible to follow for everybody. Sorry, before I go forward, I see some of the comments that some of the connection are not right. So can I ask just a quick feedback? Is everything all right? Can you guys hear me? Can you guys see me? Oh, I see. Okay, but I hope everything is fine now. All right. So in order for me to continue, so basically taking all of these is the conclusion of the slide is meant to be SRE is not just an operational function. It's not just meant to solve one problem. SRE is focusing on the entire software engineering approach to bring together and automate all of the capabilities required to build, develop, test, and run code in production and provide the creation of a value stream wide team. So if you create a capability as service, then you can own the development, the testing, and the operational aspects under the single arm. There is a ginormous amount of publicity went around it. There is over 27 different books written on the same subject. So now that we clarified that what DevOps and what SRE is, the question is, how could you go where you are today to apply SRE in a meaningful way for your own need? Now, the very first things you need to establish is culture. We focused on you build it, you own it, you run it. Shamelessly took from Netflix. The idea there is that single statement, that single sentence is introducing the foundation of DevOps culture. It already sparks the right questions of what do I need to do? What would if I want to be able to own and run everything myself? So the good thing is, by putting this out there in a very first minute, you spark the right discussions. But discussions usually become opinionated really easily. Opinionated. Sorry, I can't really speak. So in order to reduce that and have a bit more data-driven discussion, what you need is you need to start collecting data, obviously. So the very first things which we started to do is create and manually understand what the data is, what the data it tells us, and then how can we start capturing those data in an automatic fashion. Then how could we automate that data collection process in a sustainable manner? Then how can I share and make that information available for the right stakeholders, make it self-service in order to enable them to access data anytime they want, and preferably open source it so anybody can improve it further. So we introduced the cultural aspect, and we said the goal is that you build it, you own it, you run it. We collected the data, which tells you a set of story, and it enables you to set your strategies. So before you go from there, what are the under foundational layers which you want to consider? For me personally, one of the very first things which we did is settled on an immutable infrastructure as code strategy. So instead of me explaining and reading what the immutable strategy in IAC is, which I hope you can do, I want to say it. I want to explain it in an analogy. If you are in a Formula One race and you really go for winning the race, and you get a punctured tire, what you're not going to do is stop and start repairing your tire before you go back to the race. Instead, what you're trying to do is take this tire off as soon as possible, replace it with a new one, and then go back to the race. The current world record, if I'm not mistaken, is 1.7 seconds to replace the all four tires and get back to the race. And this is what immutable infrastructure strategy means to me. We do not want to focus on manually making changes to production to fix it. We want to make sure that instead of fixing, we build a new, switch over and destroy the old in order to be able to go back to the race as fast as possible. Running a live service, it really feels to me like a race because your goal is to make sure that your service and capabilities are available for your customers 24/7. So if you have the vision, you have the means to do it, you have a clear strategy, then there are going to have some requirements. So what do I need if I want to build these immutable infrastructure as a code or want to make this a reality? So we set some really clear requirements. And if I want to go to super high level as an objective, I want 0 manual steps in my process. So I want to make sure that everything which we are doing is utilizing declarative orchestration, because I only want to define the end state. I don't want to tell the orchestrator what to do, how to do it. I just want to tell the orchestrator, this is the end state I want to have. And that gives you a really good separation between doing something or defining something. I want to do the exact same things with the resource definition. And if I have both those two, it's a really good start, but I must ensure that everything which I'm doing is idempotent. If I would run this in multiple times, I still want the exact same declared outcome. I don't want to build multiple of the same things coming along. These three things of declarative orchestration, declarative resource definition, and idempotency usually nicely coupled together. We also want to make sure that every single pre and post step is packaged into a single set of containers. So everything is containerized in order to be able to ship the code and deal with it in a more automated manner. And therefore, you must ensure that there are no secret and environment config or any kind of external reference outside of your container, which you may not control. Now, if you define those 5 requirements and you know your vision, then there is only one thing left to do, is define a nice zero-touch automation strategy. So I'm sure most of you know, utilizing the CI/CD pipelines is easy. If you want to create a pipeline, it takes you literally just a few minutes. But I'm also sure that based on your experience, you will know that most of us are utilizing just CI or independently CD, but utilizing all of them in a right order, it is super hard. So what you want to do is set the objective, set the strategy, set the set of requirements, and then define what kind of strategy you would like to take in order to allow for yourself a zero-touch automation strategy, which allows you to run through your piece of code on every environment you may need, run all of your tests, functional, non-functional, and so on at the right stages, and automatically, without human interaction, enable it to go to production. Make as much decision instead of yourself as possible. So we got to the harder part now. You understand what you want to do, you understand why you want to do it, how to connect all of these things into it, and you also know that you want to have certain set of tests run in the right places. And therefore, up until now, you took the infrastructure and operational part and certain development practices into one place. However, this is where the challenge widens. What you want to be able to do is take your non-functional and functional requirements from systems-wise, from development-wise, from quality testing-wise, from performance testing-wise, from security point of view, all of them into one place. And what you will not be able to do realistically is take all of these people, put it into one big happy family team and then make it work, because you would have a ginormous size of people focusing on the same thing, and that's just counterproductive after a size. So what you could start focus on is making all the capabilities for every single team self-service. So if you start focusing on observability, or automating a functional user test, or creating your SLO and error budgets, or creating your DVT, and so on. If all of those tests are self-serving, available for anybody openly, that will result you an easier transition to define these blocks and then ingest them to the right place. So if I want to be able to run a functional user test on my PLive, then my requirement is to trigger that capability as a service, providing the right information. So in order for you, as a summary, get to the point where this zero-touch automation can work, you must enable the necessary validations to act as a service for yourself, which then you can trigger and decouple from if you like. So for me, one of the best examples are synthetics. If I want to be able to run all of my synthetic tests and I want to enable our developers to be able to own and run their own code, then what I would like to be able to do is run the synthetic tests at any of the environment, whether it's performance testing, PLive, production, or even other, and define them in a single automated way. So I hope this makes sense. In order to enable the synthetics or self-serving capabilities as a service to be successful, you need to enable those engineers to create those self-serving capabilities. Now, the engineering enablement, in order to do this, is now another tricky question. How would you do it? And every company, every team, every place have their different ones. So what I'm going to say are just some examples which we took. It does not mean is the right approach. We focused on creating observability as code. So the example there, it covers all of the monitoring, call out, all of the dashboard creations into a single set of service. How does it link to that? So basically, if we want to give our development team the ownership over their pipeline and release to production and running them 24/7, we want to make sure that they have the easiest, most smoothest way to automatically create any number of dashboard and any number of callouts. To give you an example of the size of the challenge which we had to solve, within UK in digital, we currently have about 50 development teams owning or building over 200 different microservices. Now, new microservices appearing on a weekly basis because we are trying to break down bigger microservices to smaller single pieces. And what we wanted to do is make sure that during this automated process and this transition, our development team have the simplest task, which going to enable them to spend more and more time into developing. So the capability is, if I go back to the slides, which we created and enabled as a self-service, is providing a framework. When the development team pushes a button that I would like to deploy something, it goes through the pipelines. And when it reaches P-Live and production, by default, defined as code, creates the exact same set of automated dashboard, call-out rotation, alerting rules, which they are free to modify if they like. However, it happens automatically upon every single push, and therefore, it's always there for them. So that kind of enablement, which I'm talking about. So we did observability as code. We created the pipeline framework and the creation of any kind of testing pipeline as code. We created the capability to request any number of environment on demand. So if a development team needs a functional user test or a path testing environment, they go run a pipeline in 15 minutes, they have the environment ready, which is going to be destroyed after they finish their work. We created environment schedulers for the environments which we cannot or do not wish to destroy. We created an automated cloud cost tracking capability, so enable the development teams to take full control and ownership over their cloud budget and utilization. We logged down our productions in systems, so therefore nobody can make any manual changes to them. Every change must go through the pipelines, and that's enabling the teams to make sure that they are capable of using consistently all of the additional capabilities. And we implemented break glass rules that if for any reason somebody has to touch the production system manually, then we have a means to alert, notify, and after fixing the issue, resync all of our automations to make sure we're never going to go out of sync from there. So to recap, what I said in the beginning is DevOps is a set of culture. SRE is the engineering discipline, which defined by Google to create that. As I went through, and I hope it was useful, the SRE team is focusing on self-serving capabilities and enablement in order to enable the development teams to take ownership, focusing on culture to set the right tone of why we want to do it. We want to make sure that the same value stream who starts the development project with an idea have the capability and empowered to go through every single development cycle, from developing to testing to releasing to production and running it end to end. It's your baby, and you don't give it away. You stick with it until it grows old. It sets the right requirements and gives the right tone of automation. If we understand that, then I hope this slide is going to be useful and meaningful. What we set as a goal for ourselves is DevOps is a set of culture we would like to focus on, but we would like to implement DevOps with the SRE principles. And we set these culture and principle aspects to all of our engineering goals from the start. And that was a really powerful and very good motivation to trigger such a transformation from our end. When we started this, and just to show the result which we managed to achieve, this is in the last 2 years. So we started this movement in November 2019. We defined the plan, the strategy, started to create the SRE team. And the SRE team got involved and took ownership over operation in March 2020. And when we did, we saw a big difference already, shifting and starting to monitor, first of all, because that was the first time when we monitored service availability, which is inherent, and customer experience, customer availability, which were never differentiated before. So when we started to work on this, our service availability, inherent availability, started to go up and up and up. And our customer experience, it moved on their normal expected trajectory. Then we started to focus on infrastructure as code, and between the SRE team started and infrastructure as code created with the right capabilities, our number of releases started to grow and grow, and it's still growing on a daily basis. And when we introduced IAC and then went over to zero-touch production, we managed to completely eliminate all of the security issues and alerts which we had in our systems, which is a really, really powerful way to show that the results speaks for themselves. What the business saw from this at the end was over a 97% improvement time to prod. And we were talking about weeks of being able to release something, because the stages between those steps were manual, and even just configuring the environment and keeping them aligned was really time consuming. Setting these automations up meant that I'm capable of releasing a piece of code in less than 4 hours from the dev environment up until the prod running through all of the tests, which is a massive difference. Infrastructure scaling time is something which is drastically changed as well. But AWS costs being reduced by 60% is something which is, again, the businesses deeply care about. Imagine if you could say to your organization, I can save more than half of the money you spend on infrastructure. And we managed to do this with these basic principles. We created the environments which are only used 4, 6, 8 hours on a daily basis, but the rest 16 hours, they're not needed. So instead of standing there running on full speed or standing there by being shrunk down, we literally destroy them. The fact and the power of the cloud is if you don't need something, you don't need to pay for it. So if you have the capability to only build it at will and destroy it at the end, that saves a massive amount of money. And this is why we started to focus on a PR environment, which is basically the push request environments when you try to develop something and merge something. We just automatically create the entire environment, run those tests, and then make a decision whether they should be merged or not. And if not, just destroy the environment after that. We reduced a huge amount of bugs, and we reduced a massive amount of security risks in production and lower environments as well. And to conclude the whole presentation, we then went from the UK and started to talk with other colleagues from other side of the globe within Vodafone, and checked where they are in their current transformational journey, start applying DevOps and SRE. And from these learnings, we created this really simple maturity sign, the board, where we said the very first step is obviously try to get some of the people have an SRE team, have an understanding of what's the vision, and be responsible for the actions. Then some of the pre-requirements in order to do this to make sure that your infrastructure or your application, your requirements are actually cloud ready. Then you want to make sure that your application and piece of code you want to be able to do is actually containerizable. If you got all of these, you have a team, you have cloud ready capabilities, and therefore you can utilize cloud, and your piece of code is containerized, then your next natural step is to be able to do zero-touch production. If you can lock your production down because of the three things, you can then create infrastructure as code. Infrastructure as code is going to be the one which enables you zero-touch production. From that moment onwards, we were able, so if you got to the point where you can build infrastructure as code, you can monitor your services via a predefined set of pipelines. That means you are capable of locking your production down for manual changes. From that moment onwards, you are capable of running a more mature set of improvements which is going to enable you to utilize the full potential of the DevOps and SRE culture. So we said that once you have zero-touch production, observability as code, single pass to production, CI/CD pipelines, the quality gates for the pipelines are all could start in parallel, and you can. There is lots of work, and I don't think we are there utilizing any of these full potentials yet. But ultimately, what is going to enable you at the end is have a really meaningful data-driven discussion between achieved versus inherent availability. And this is the last bit which I would like to mention. Achieved availability or service availability, you can imagine it like you are owning a web shop. The website is up. The people are capable of browsing and deciding what they would like to buy. However, when they click to purchase, and let's say it requires them to provide their postcode or something, and that service does not function, it may be completely out of your control. You don't even own this. You just utilize a third party to take payment or something else. Your service availability, the bits which you control, and therefore that's your inherent availability, that may be 100%, and this is as best as you can make with the current capabilities you have, which is awesome. However, the achieved, the customer experience might be that although everything seems to be perfectly fine, when the person trying to fulfill the task which they came to do, for example, purchase a phone or do whatever action they like, if they cannot do it, then your achieved availability is still going to be reduced because the customer is going to experience an error, unplanned error. And that's it. That was me. I really hope you guys enjoyed it, and I hope it provides some insight into what we did so far. Thank you very much for having me.
Thank you, David. Nice stuff, insightful stuff. I like it a lot. So, Nick, you have something to share with us?
Yeah. Thank you so much, David. And I guess we'll see you on the Q&A session. That's going to be
Thank you, David.
Thank you.
An hour and a half. Yeah. All right. So yeah, I'm just going to leave a quick link in the chat. It's from one of our sponsors, JFrog. So it's a survey that asks you to check how mature is your DevOps process. Yeah, I'm going to leave it in the chat. And yeah, stage back to you, Rui.
Okay. We will have a short announcement again.
No, that was it. That was it.
That was it. Okay. Thank you. So our next speaker is Dean Schuster from the United States. He's the owner of the TrueMatter company. He is the founder and is a partner of the company TrueMatter, that is a user experience strategy firm. Dean, are you with us? I think you're mute.
And hello.
Hello, Dean. Thank you very much for your presence, and the stage is yours. Thank you.
Thank you. All right, I'll get started. I'm going to go ahead and share my screen. And let's see here. There we go. You should be able to see my screen. Ta-da! And if there's a problem with sharing my screen, just I'll ask the host to speak up, but otherwise I assume it's going great. Thanks a lot for listening to me today. Again, my name is Dean. I'm a space nerd, and we're going to have a little bit of fun today. First, you can find me on Experience Dean on Twitter or Instagram. And yes, I'm partner and co-owner of TrueMatter. You can find us at truematter.com. And we do UX, nothing else. And for more than 20 years, we've been solving really difficult digital product problems, specializing in complex software. So we're working with development teams using a variety of processes all the time. So we've learned an awful lot about how to partner UX with advanced development. But today, we're going to have some fun and talk about what the Soviet space program taught me about digital product development. I'm totally serious. That is actually what we're talking about. And it is amazing that what happened a long time ago, this is like 60 plus years ago, in the USSR, can inform what we do today, but it truly can. So we're going to go back in time a little bit and get through a lot of history really quick. Right, the year is 1968, and these two little step tortoises make history. All right, the Soviet space program is going to launch them into space. They're going to go all the way around the moon and come back safely to Earth. They'll be the first Earthlings to fly around the moon. A very important first for the Soviet space program, who at that time was used to being first at basically everything in space. Now, that the ship, the craft, was called the Zond 5, and it flew around the moon just as planned, but it had difficulty re-entering the atmosphere, right? It had a malfunction, and it had to sort of crash land in the Indian Ocean instead of on land. And the United States figured this out, and they sent a boat to go see the Zond 5 in the Indian Ocean and take pictures as fast as they could before the Soviets could retrieve it. And this is one of the pictures they took. This is the splashdown of the Zond 5. Now, when the Americans studied these photos of the Zond 5, it confirmed for them what they had known or suspected for years, that Soviet technology at that point was far, far behind American technology. And the Soviets were actually no threat to beat the Americans to the moon. And 3 months later, just 3 short months later, the United States sends humans in Apollo 8 around the moon and back safely, no problem, no malfunctions. And the USSR abandons any practical hope to get to the moon first. So the question I ask is, what happened? And in order to understand what happened, we're going to go back in time even a little bit more before the space race to tell you why it all happened the way it did and how it can teach us something today. So this might be, for younger people out there, this might be somewhat new because not a lot of young people know a lot of this history. And that's anywhere around the world. Certainly not in the United States. Not a lot of young people know this. But let's go back to the end of World War II, and the Soviets were the first to get into Berlin. And one of the big things they did was they captured a lot of German rocket technology and a lot of German scientists. And one of the specific rockets that were captured was the V2. And this was a new rocket technology. And they see the promise of this for warfare, right? They want to exploit the V2 for warfare. Now, of course, as we know, as time went on, the Soviets become a nuclear power, and they realize that they can put nuclear warheads on the top of rockets. And so they build a very big nuclear rocket program. This is the ICBM program, the Intercontinental Ballistic Missile Program. So by the 1950s, both the United States and the Soviet Union, they've got a lot of nuclear weapons. And this concept comes up called MAD, Mutual Assured Destruction. All right. We both, United States and Soviet Union, wanted to avoid all-out destructive conflict because of the nature of nuclear weapons. So we settled on conflict by nearly all other means: political, scientific, athletic, territorial, military weapons, and of course, space. And so now the Soviet Union is exploiting rockets to the full, and they develop a fast-moving space program, and this births the space race. Neither side wanted the other to be the first to exploit space for military purposes. It was all about military might. The game's afoot, and the race to get humans into space begins. And of course, the holy grail of the space race is the moon, a pinnacle achievement for humanity, an ultimate winner-take-all prize in the Cold War. And the USSR, of course, takes a lead right away, as we know. In 1957, the Soviet Union is the first, always the first, to launch a satellite into space. This is Sputnik 1. And it's fair to say that this caused grave concern in America, because this is just 12 years after the end of World War II, and up in the sky over our land, we like, oh no, there's a Soviet satellite. What does this mean? Are they spying on us? Is a militarization of space happening? Are we losing? And it's a big deal. It freaks Americans out, basically. Now, the Soviets weren't just first then. They were first to nearly every milestone in space. Let's rattle them off. First crewed space flight, first animals to orbit the Earth, first person in space, first person to orbit the Earth, first flyby of the moon, first photograph of the dark side of the moon, first flyby of another planet, first woman in space, first spacewalk, first landing on another world. They were first to everything. But we know that the United States caught and surpassed the Soviets. We know this from history. America, spurred on by John F. Kennedy's impassioned speech, we choose to go to the moon in this decade, not because it's easy, but because it's hard, that sort of thing. And Americans get excited, and they develop a space program to rival the Soviet Union. And by 1968, not long after, with Zond 5 and the tortoises, it's clear that the United States had the superior program. And we know this because the US wins the space race, right? We get to the moon first, right? That is an American flag on the moon, not a Soviet flag. So the question is, why did the space race end up the way it did? Why did it happen that way? And why does the Soviet space program suddenly remind me so much of what I do every day, of digital product development? These are my questions as I look into it, because there's some similarities, right? Both the Soviet space program and what we do today, modern digital product development, are deeply based in high-tech engineering processes. They have a design or experiential component. They burst into the mainstream, drove economies. I mean, the internet as we know it today essentially comes from the space race. These are activities of making. We're making things and putting them out there in the world, and they're set in a wider context, right? For the space race, it's politics, but for the things we do every day, development, it's the market itself. And the Soviet space program actually has a lot of things to teach us, and I'll call them cautionary tales, all right, full of stuff we should be concerned about or warned about. And I'm just going to show you a few today. So let's begin and let some beautiful Soviet era space propaganda guide us through. First point is about speed, And this was very important to the Soviet Union. Now, the Soviet Union was seriously focused on being first. They threw everything into this effort. They bulldogged it. They bootstrapped it. They worked under unconscionable time pressure. They worked so fast, they weren't testing things prior to launch. They were just going for it. Dates were relentlessly driving everything. That means process, goals, methods, quality, safety, such as they were. And to give you an example, we'll look at the first spacewalk. Now, in 1965, Alexei Leonov, he leaves the Voskhod 2 in orbit around the Earth and performs humanity's first spacewalk. Right? The Soviets were utterly determined to be the first to this milestone, right? And they cut a lot of corners in order to do it. So let's look at that Voskhod 2 mission. Now, Voskhod 2 was really just a down and dirty retrofitting of, you guessed it, Voskhod 1. And it was created expressly for the purpose of doing the spacewalk. That's it, right? Now, the Soviets moved recklessly. Let me give you an example of what they did with the Voskhod 2 in order to get it done quickly, super fast. First, the ejection seat removed. The crew module was still run by vacuum tubes, so it could not be opened in space. So they need a solution for that. There was absolutely no provision for the crew to escape at launch or landing. And Leonov himself, amazing guy, he wears an experimental spacesuit for the very first time, never been tested. Now remember, you can't just open the door of the Voskhod, right? Vacuum tubes. So they need to figure out a way to get Leonov from the module into space and back. And they need an airlock. And so they devised, this is true, an untested inflatable exterior airlock that they had to affix to the door when they were up in space. Now you can see a picture of this airlock in the deployed position in this graphic. Now, Leonov does do the spacewalk, and it's 12 minutes of very scary, harried time. First of all, he gets out into the area outside of the craft, and his spacesuit instantly expands, and because of the atmospheric difference, and he's got a problem because now he's too big to get back into the craft. So he's an amazing guy. By the way, he painted this painting you're seeing here today, an artist as well as an amazing cosmonaut. He invents oxygen from his suit in space. It's the only way he can make himself smaller to get back in the craft. This gives him decompression sickness, by the way. And he had very little bit time to get back. He has to go back into the airlock itself, but he goes in the wrong way because he's hurrying and he's freaking out. He goes in head first, and he has to turn around in this thing, which is nearly impossible to do. And time is running out. And he finally does get in, but his heart rate was mega elevated, and he was sweating so much that he fills up his boots to overflowing with sweat. He was freaking out. An amazing guy freaking out, right? It's basically a miracle he didn't die. Any one of these problems could have caused him to die, no doubt about it. But that's not it, because re-entry actually malfunctioned when they went back down into the atmosphere, and they had to do an emergency landing in the Ural Mountains. And so he and his co-pilot had to spend 2 freezing sub-zero nights in the Ural Mountains before they were rescued. It's a pretty shocking story. I haven't even told you all of it. Really, you should Google it. It's very eye-opening. Now, further Voskhod missions were canceled immediately. They were deemed too risky and too dangerous. And for the Soviets, that's like totally saying something. Now, the comparison. Because before you think it's unfair of me to compare modern software development with the Soviet space program, I want you to consider the track record, not just of the Soviets, but of us, right? As amazing and as life-changing as it's been, the software development industry is not exactly known for rigorous, error-free products, right? Today, we're decades into the information revolution. Digital products are still shipping with swarms of bugs and substantial user experience flaws. Somehow, some way, we've grown to totally expect this and even tolerate it, so much so that we give it a name. We give it a name, and that's MVP, minimum viable product. Now, no industry is perfect. Right, but we seem to have cornered the market. Okay, minimum viable is kind of a rule of the day in development teams. Now, to be fair, there's lots of good here, right? Because there was problems with the development process, and correction was needed, right? We needed to solve the problems of bloat and delay culture and too big features and black box development. These were serious problems, okay, that MVP is designed to address and address fairly well. The problem is we have so much faith in the new model of MVP, right, which is to incrementally deliver a high visibility, evolve continually, right? These are good principles, but we have so much faith, we have to ask ourselves the question, have we sacrificed something for greater speed and time to market that MVP gives us? Have we sacrificed? I'm going to say, yes, we have. Because digital products, last time I looked, they're still shipping with errors, still, and lots of them. And those rampant, user experience problems, they've not gone away. Okay. You can only look to, a crazy example like folding phones, which came out years too early, and were, completely unreliable, and they broke and all sorts of stuff. And it'll be a while before we get them right. So it feels like we're back where we started. Lots of bugs, poor user experience. We just sort of changed the way we got there. So this promise of MVP, of refinement and evolution, things will get better. That's amazing. But in our experience, in 25 years of work with a lot of dev teams, most MVP products shipped are rarely adjusted significantly after the fact. Most groups just move on to the next or different MVP. So we have to do better. I mean, we have to be incremental and nimble, right? But we have to make better experiences. We have to make higher quality software. That means easier to use, more error-free, responsive, courteous, convenient, right? That's the promise of MVP that we actually need to embrace further, right? More quality, better user experience in digital products is well worth the trouble and certainly the little bit of schedule. Now, do you want to know how I know this? I know this because of the Gemini 4. All right, 3 short months after the Voskhod 2, which nearly killed Alexei Leonov, the Americans sent up Gemini 4. Right now, Gemini technology was roundly superior in every way to the Voskhod, far safer. The U.S. astronaut Ed White, he spends 20 minutes in space. He's chilling out. He's taking pictures. He is not in a hurry to get back in. Everything goes fine. He's overwhelmed, like Leonov was, with awe and emotion at what he sees. But when they finally force him to get back into the capsule, as he's closing the door, he looks out and says, "This is the saddest moment of my life," that he had to go back in and go home. That is extremely different from the Voskhod. Okay, that's a big deal. And they couldn't be more different. I mean, Ed White very nearly was the first true man to walk in space because Leonov could have been killed at any given point. All right. So Leonov's awesome. A little bit of luck there. And the Americans only did this a few months later, just a little bit longer, and they had a way higher quality experience. So in our circle, as development teams, as development leaders, we have to show leadership. We have to show leadership and accept and demand the higher quality, better user experience option that often just takes a little bit longer. Next, I want to talk about the Korolev effect. One person alone can't save the day. I want you to meet the Integral. He's a former colonel in the Red Army. He became chief designer of the Soviet space program. This is Sergei Korolev, right? He had been thrown into a gulag by Stalin. He was released because he knew rockets. And he becomes the driving force, really the genius behind the Soviet space program. He was the man. He uses expertise in rockets to create the space program. He convinces Khrushchev that the space program is valuable in and of itself, even if it's not military, just for its propaganda quality. And Korolev shows us that one person can change history. And he became totally essential to the Soviets. He led all aspects of the space program, including goals, planning, designs, mission, processes, technology. If something happened, if anything happened, it was because of this guy. Unfortunately, in 1966, Korolev dies suddenly, and he dies at the height of the space race. And the Soviet space program was already barely keeping ahead of the Americans. It was never the same again. And the real problem became when other people tried to fill in behind Korolev. That showed that the Soviet program was fundamentally flawed because there's this power struggle, and Soviet efforts become even more reckless, if that's possible. And the first post-Korolev launch was Soyuz 1. Despite more than 203, let's say over 200 design faults reported by the engineers, Soyuz 1 still was commanded to be launched, and it encountered a series of failures, of course, that ended in an ignominious first, the first in-flight space fatality. That's Vladimir Komarov, pictured here in any space program. Now, let's think about us again, because our industry is strongly personality driven. Now, we're not alone in this, but it feels a lot like a feature more than a bug for us. What happens when key people leave a project or a team? Teams, whole orgs can become dependent on dev superstars. There's no question about this, especially now as people are moving quite a lot in the employment space. There's dependence on specific domain knowledge by a select few. This means highly motivated political players can drive projects to success or ruin all by themselves. Now, we need processes that don't need us. And it's hard to create that. I get it. It's hard to create processes that outlive superstars. But one of the ways we can start is to bring more types of people onto our dev teams. We need to open up to other disciplines like user experience, front-end expertise, accessibility, content strategy, yes, design. And of course, open up to user participation. Now, there are myths associated with a champion in any project. They seem like they can run it all, but in reality, there's underlying problems that are left. That was true with Korolev. It's true in any case with us, in any case. And we have to do better at that front. That is not easy. That's a topic of an entire talk in and of itself, but it's important for us. Very clear parallel. All right, one more. Let's talk about reality. And reality being what we make of it, kind of. This is the masthead of the old Soviet newspaper, Pravda. Right? This is the propaganda vehicle for the party. Now, Pravda means truth, but truth is malleable. And the Soviets were really good at molding narratives. You remember the Zond 5? We started with the Zond 5. That mission barely succeeded in 1968. It carried tortoises, not humans. It crashed in the wrong place. But the Soviet Union proclaims glorious victory with posters and artwork and commemorative stamps. They were making it more than it was, sort of a last gasp propaganda win. You know how I know this? Let's look at the date on the stamp. By the time they put this stamp out, it's 1969, and something else is happening in 1969. Oh, yeah. Their rivals, Americans, are walking on the moon and sending people back to Earth. So the Soviets were really good at propaganda, even when things weren't as good as they seemed, and certainly amazing at it when they were completing all their amazing firsts. I mean, just look at some of this rich propaganda work they did. There's a treasure trove of art that really drove everything the Soviets were doing. This is, glory to the fatherland of heroes, glory to the first woman cosmonaut into space. This is great stuff. This is amazing. Let's get the children motivated. Wonderful stuff. And the goal, of course, and by that I mean the art is wonderful, right? The goal of all propaganda is to drive reality by force of will. And in so doing, you're motivating and manipulating a population. It's a form of control, humans desiring to wrestle chaos. And in the Soviet space program, truth was only tangentially related to what actually was happening. Timelines, they were all driven by key anniversaries of what the US was doing or important Soviet communist anniversaries, not by technology, not by safety, not by quality, nothing. All these pronouncements reinforce the system and the philosophy itself more so than the achievements, and political concerns absolutely superseded everything. That's technology, safety, schedule, and of course, people. Now, think about us in digital product development. Propaganda is not the exclusive province of countries. Plenty of us play in this sandbox. Product launches and decisions are timed to competitors. Trade shows are artificial deadlines. Announcements are intended to procure a sale, a deal, or to placate investors. There's exaggerated claims about little incremental updates. We overpromise features without consulting teams. We are awash in propaganda. But just like with the Soviet space program, it's all veneer. It's all surface. It's all talk. All right, let's look at some lessons. Now, engineers drove all of this innovation. It's wonderful. And the lessons they learned can, in fact, help us. Let's look back at what we've learned here. And first is that your model drives your methods. Different philosophies, right, means something. How you conceive of your mission and your work determines what you will do, what you'll make, how you'll make it, how you'll sell it. Now, Soviet goals centered primarily around propaganda wins and being first, and they achieved this for a while. But different results occur. Your starting point does matter. If you just want to get to the next release, if you want to be first, whatever, you can do it. You can totally do it. If you want to build quality digital products that will last long, you can do that too. You can do that too. It's a choice. And so our choice is to learn, to adapt, to avoid the problems of the Soviet space program. I mean, it achieved amazing things, but ultimately didn't achieve its broader objective. And so our goal is to do, I think, 3 important things to avoid these mistakes that were made by the Soviets. Invest in quality, particularly UX, even if it takes a little bit longer, just a little. We need to build systems and processes, it's a great topic for this conference, that outlive us. And we need to avoid artificial push and artificial meaning to what we make. Now, to conclude, we're almost always doing better, I think, than we realize. The Americans were paranoid about Soviet success way up till near the end, but they were actually doing a lot better by the mid-60s, right? I want you to look to NASA, which is the program that is just behind the Soviet Union for most of the 60s, but ultimately is the force that overtakes them. If you think it's impossible to hit aggressive development deadlines while simultaneously creating high quality user love products, or if you think that's hard, if you think that's super crazy and impossible, we put humans on the moon. All right. It wasn't perfect. All right. We moved fast. NASA had to invent along the way. They had to figure out reliable solutions to completely novel problems. It was done with professional excellence and marked attention to safety, despite the fact that there were problems in that program as well. But comparatively speaking, way safer, way better in terms of technology. And NASA essentially beats the hyper-competitive Korolev-led Soviet space program, the less careful Soviets, to the punch. That wasn't impossible at all, okay? And I assure you, the problems they were solving are way harder than the problems you're solving. It was not impossible. It was just extraordinary. And that's how I know you can do it too. I can do it too with my team. And that is what I learned about the Soviet space program and digital product development. Thank you so much for listening. Again, my name is Dean. You can connect with me online any way you want. I really appreciate you listening. I'm going to go ahead and stop my screen share. All right. There we go.
Thank you very much. Well done. You have a very good story, a very good parallel that to present us. It was amazing. Thank you very much.
Appreciate it. Thank you so much.
Thank you. So we have a short announcement.
And now I want to say a huge thank you to our friends and our sponsors at Neurolegion. Thanks once again for joining us and for sponsoring this event. And just a couple of quick words about their API and their security testing scanner. What's so awesome about their product? So basically, it's built by developers for developers, and it helps you to integrate your security testing, gives it into the hands of your developers and your QA engineers and DevOps engineers. And it built for developers. It produces no false positives. It's easy to use and fast to integrate with your CI/CD. You can test your applications and APIs, SOAP, PRAS, GraphQL, you name them. And you can do it on every build, basically. So no manual validation. You don't have to go through the findings. Once again, it removes false alerts and human bottlenecks that cripple your rapid releases. It will speed up your releases, and also it's developer friendly. It has the remediation guidelines are very simple, and you can start fixing your security issues. You can start fixing security very often now. It makes it so easy. So have a look into their awesome trial. And also we will announce a hands-on workshop for where you will actually install it, register, you will receive a free trial. And basically you will have a hands-on workshop. You will do the repo, you'll set up the scanning, and in just a couple hours, you will learn some awesome tricks that you can use in your DevOps day-to-day practice. Thank you, Neurologian.
Okay. Our next speaker is Johannes Haux from Germany. He's the managing director of Sysmagin, and he will talk to us about going beyond the basis on code reviews. Johannes?
Yeah, thank you so much for the short introduction. Just to clarify, I'm one of the managing directors, and I'll be talking about code review today and like a more technical perspective on code reviews.
Okay, the stage is yours, Johannes. Thank you.
I am sorry, I didn't get that. Louis, if you just said something.
The stage is yours, Johannes. Feel free to start.
Stage is mine. Perfect. Thank you so much. I'm sorry for the confusion. Yes, I'll be talking about how to use Git for code reviews and during code reviews. So this will be a bit of a more craft-focused talk and less conceptual. To understand why I'm the one talking to you, let me quickly introduce myself a little bit. Here you can see me back when I was at university. I just started coding because I switched to computer vision from mainly studying physics. I even used Git, in the most proficient way possible, and was pretty sure I really nailed this whole software development topic. I was pretty confident about that when I started looking for jobs, and at some point found my partners and then joined Sysmagin. And sure enough, I was quite happy. We are working on an amazing new technology. That's merge board logo. Check it out at some point if you want to. I learned a lot of new concepts software development wise. So you can guess, before everything was self-taught. Now I had two amazing teachers, my partners. The only thing that kind of nagged at me was that my code reviews always took a lot of time. The thing that I noticed at some point as well was it was only in my case, right? Things that I pushed would usually take up to a week before being merged. Luckily, as I said, my partners, very versioned, very experienced software developers, they then talked to me a little bit and taught me about Git. And this is what we'll be talking about, how to make sure that your Git history is in such a way that code reviews are easily possible. Now, just as a quick recap, what is Git? We've heard it today a lot, right? Everybody's using Git for GitOps, for basically anything software development related, because Git is a version control software. It lets us keep track of changes, which is super important, especially if you have bigger code bases. Code review, on the other hand, lets us understand changes. It makes sure that everything works as intended, right? So these two should probably go well hand in hand. Now, there are a few things to consider to make sure this is actually the case, and we're going to study them. Now, the first thing you probably all have heard when it comes to being a successful Git user is that you want to have small commits, right? Small commits usually also ensure that you have a clean Git history. A clean Git history I would also define as one that not only has small commits, but commits that, of course, do one thing and one thing well. And with well, I mean everything in that commit works. For example, you could test this if your tests are passing, right? Right, so this is what we're going to focus on today. As I said, this will be a crafty talk. I'm not going to go into the details on how to give a good review, on how to give good feedback. There are actually very, very good blog posts out there. I can really recommend those by Michael Lynch. And yeah, those focus more on the personal side of things, also a bit technical. But we are really focusing on Git today. And everything I tell you today really only works well if you also behave professionally. So check out those blogs and then apply anything you learn today. All right, let's talk about how to craft small commits. And this will be something I will demonstrate to you live. For this, I've prepared here a terminal on the left side. On the right side, you can see the current project structure. This is a tic-tac-toe project, but the content of the code is not that important. Below, you can see the output of git status. This is basically git status being called over and over again. So you can see as soon as I stage something, you should notice here. And below, you can see the output of git log, so our current commit history. I'm currently preparing a merge request. Back before I started working, we only had an implementation of this backend, and I now added a front end and also made it possible to play this tic-tac-toe game by crafting an entry point and also linking this entry point. And I wrote a lot of documentation. Now, I already created a commit where all the player-facing logic, so frontend.py has been committed. And now I'm thinking about what to commit next. As I already said, a good way to craft commits is to make sure they only cover a certain topic. So I already talked about two topics, which was creating an entry point, making the game playable, and writing documentation. So I want to split the rest of those changes that are currently here along this topic or these topics. Now, the problem is, if we look at the setup.config, we can see that it has changes that are concerned with the documentation and changes that are concerned with the entry point of the of this app. So how do I commit this, right? How do I make sure that I don't have to commit all three files because, well, I have changes in one file that concern two topics? And Git, of course, has us covered here. I can simply call the git add -p option, which lets me add parts of a file. So next, we want to commit the entry point. So let's do just that. If I now call the git add -p option, Git will open a dialog, an interactive dialog that asks me, what do I want to do with this part of the file? Now, with this part of the file, currently, I don't want to do anything. So of all those options I have down here, I choose the N option, which says, no, I do not want to stage this part of the file. Enter, and then the next part of the file this is something I want to stage right now. So I choose the Y option. Yes, I want to stage this file. And with that, we have this part of setup.config staged. Now, let's also add the main.py file. And now, one command that is super important before we even think about committing. Let's make sure we only have staged anything that we actually want to commit. For this, use the git diff -- staged option. What we can see here now is that, yes, we only have have staged part of the file of setup.config and the entirety of the main.py file. Very well. Now it's time to commit. Back in the day, I usually did something like this. I would recommend you not do that, but simply call git commit. This opens your favorite editor. In my case, this is Vim. And now you would enter a nice commit message. I have one prepared, so I don't have to write this out here. One way to craft good commit messages, and again, there's a lot of blog posts on this topic out there, is to make sure you have a concise summary on the top and then a nice body, which then also adds more explanation to what you're doing. It's better not to talk about how you do stuff, but more about what and why you do stuff. All right, I save and quit this message. And with that, our commit has been added to our Git history. Next thing we want to do is we want to stage and commit those 2 remaining files. You could do something now like git add -a, which would add all the files. But this is sometimes dangerous if you have files flying around that you maybe don't want to add. In our case, we only want to add updated or modified files, which is a lot more safe. And this is why we use the git add -u option. You can see right here in the output of git status, they are now staged. So we can go about checking again if what we staged is what we wanted. And yes, we see readme.md has been added and only the part of setup.config that we wanted to add. Perfect. Let's commit. Again, I have a message prepared so that I don't bore you with writing it out. And I save and quit. And now our git log looks like this. Let's take a look at it here again. This is now a nice git history. So what we can see here is each commit does something like small topic-wise and yeah, can be looked at on its own. That's what we want. Let me just write this out so that we can take a look at it later on. Perfect. Everything that's left to do now is to push. And that would now be the time that we open our merge request or pull request and a reviewer would take a look at our changes. Now, I won't open the merge request, but consider our reviewer working right now. They're checking our changes. So we have time to take a look at what we learned. Now, what we talked about was we want to make commits based on topic, and we rather prefer smaller commits than larger ones. We can do this with the -p option for staging files. The -u option allows us to add only or stage only updated files. And a command that I really recommend you use all the time before committing is the git diff -- stage command, which lets you know what will be committed once you actually do commit. And then finally, I recommend you craft your commit messages by running git commit without the -m option. with the intent to have a small summary with a more descriptive body in the end. Now, what happens if I screw up, right? There are, of course, first aid commands Git offers you. One would be the restore command, which lets you restore, for example, staged files, so they are unstaged again, so you don't commit them. And of course, the reset minus soft option, which resets the state you are currently into that of this commit without losing the changes you made. This is why you pass the minus soft option. So you can, for example, recraft commits. Perfect. And what's this? Oh, our review's in. Perfect. Let's see if we got blazing scores. Well, there looks like there is a typo. Not so bad. Oh, but we also have unneeded print statements, and the main branch has changed. So yeah, looks like we have to change things in all the commits. Doesn't that mean we have to, I don't know, get rid of our clean Git history we just crafted? Luckily, the answer is no. And we are now taking a look at how we can keep a clean Git history. For that, again, I'm going to switch to the live demo. And yeah, just check if I see all the comments. So if you have questions, feel free to write them down. I'll try to answer them. Yes. First things first. Let's change this typo in the README. I open it again with Vim. I know where this typo is, so I can search for it. This should be moves and not movies. So I save and I quit. Now you can see the file has been modified. If I edit, again with the -u command, only updated files, it's staged. And if I now check, this output is not very helpful. Quick tip, I literally learned about this command like a few weeks ago at the -word diff, and you get this output. It's amazing. It helps a lot for changes like these, where you only modify a single word. Perfect. This is what we want. And now we commit. No, at least not just like that. What we want to do is currently, we want to change changes in this commit right here. How can we do this? For the last commit in the Git history, Git offers you the git commit -- amend option. If we hit this, we can then confirm the commit message. I write and I quit. And now this change we just saw is also part of the latest commit in our Git commit history. So super handy if you are working on a certain commit. That's now the latest one in the history. Let me again save out this log so that we can take a look at it to better understand what happened with the git commit -- amend option. For this, we switch back to the presentation. What we started with was this Git history. What we are currently seeing is this Git commit history. It looks basically the same, right? The commit messages are the same. But you might notice that while these three commit hashes here are the same, the last one is not. So what git commit -- amend does is it replaces this commit here, the latest one, or the one here in our feature branch, with a new one, and now then puts head back to this commit. So you basically now have a new history, a new Git history. All right, but there is more we need to do, right, in our review. Let's switch back to the live demo. We learned that the main branch has changed. I'm sorry, my cat is currently making a fuss. Maybe it wants to get outside. Yeah. That was Tucker, by the way. He's not on Imager, not on Instagram, but yeah. Anyways, back to the topic we are on. We learned that the main branch has changed. Let's literally check it out. The log shows us that we branched off here. But basically, I know this. It doesn't show this here. But then a new commit has been added. And what we want now is we want to put our current history on top of this commit because it didn't change anything in the files we worked in. It just added one. How do we do this? It's actually super easy. What we are looking for is a new base for the history of our branch. And yes, Git gives us just this command. We can simply say rebase our current history onto the main branch. We hit enter. And what you can see is that this commit now is part of our history. Amazing. Already 2 of 3 review change requests implemented. Again, let's save out this log and take a look at what happened in the presentation. Now, git rebase. This is what we worked with, right? We have our main branch here with a newly added commit with our feature branch that we already updated before. And now we want to basically have this branch off from this M2 commit here. Again, if you look at the output of the git log statement, we can see that this commit has been added. It's missing up here. We can see that the commit hash of the first commit has not changed, but all the other hashes have changed. So why is that? The reason, again, is pretty similar to what happened with the ---- amend. Git moves the head pointer where we are currently down to the M2 commit here, and then basically applies all the commits one by one to this history or to this after this commit. So it creates, again, a new history by simply applying the changes in the commits we saw before, giving them the same commit message again, so the history looks very much the same. The cool thing is we can use this stepping through the history now and work with that. Let's see how we can do this when we want to actually fix the other bug we still have. Now, what we can do is we can start an interactive rebase. So that would be rebase with the -i option. Again, we want to rebase on the main branch. This won't change the history here, won't introduce any new commits. It just makes sure that we talk about these 3 commits. If I call this command, what happens is my editor again is opened, and I can now tell the rebase what to do when it's at each commit. Super powerful tool with a lot of options. We will only take a look, for the sake of this talk, at the edit option. So in this first of 3 commits, we want to change something in the file here. So we say, once you are at this commit, once you have applied those changes, stop and let me do some edits. That's why I put the edit here. And then we can do our changes, and then it will continue applying this rebase. Let's check this out. I save and I quit. And sure enough, we can see that we are currently at the commit we want to be at, right? This is, again, the output of git log. Our head is at this certain commit. And now we can actually apply those changes we want to add. So we want to change the frontend.py file. There was a print statement we wanted to remove, and that's this one. I delete it, I save, and I quit. And now the output of git status shows us, right, this file actually has been changed. So let's add it. Again, -u option. Let's check that we only stage what we wanted to. Sure enough, we did. And now you already know what to do because we already learned about it. We simply have to amend those changes to the current commit we are looking at. So let's do that, save and quit. And now those changes are part of this commit. All that's left to do is to say git rebase -- continue, which now makes sure that all the other changes in our branch are also applied. Perfect. Here you can see that the history now looks as it should be, as we wanted it before with our 3 commits we made in our branch. So we have implemented all our feedback, and all that's left to do is to push, right? Well, yeah, that's a problem. The push has been rejected. Why is that? Well, as I told you, we have changed the history of our branch, right? Our remote, in my case, that would be GitHub, has no way of comparing what's happening. For example, if I simply append a commit, it could just say, okay, this commit has been added and we're fine. In this case, there's nothing it can compare. So what we have to do is force push and overwrite the history on our remote. This is super dangerous, I have to tell you here. As long as you're not working on a branch where you're the only one working on. So never do this on main, never do this on master. Your colleagues will kill you. Let me tell you about it. Yeah, I did that once. Wasn't very nice. As long as you're working on your own branch where maybe your reviewer checks it out or something, this is a totally viable way of going about things. Don't do it with other people working on that branch. All right, recap time. What did we learn? We learned how to amend, how to update the latest commit in our Git history. We learned about the interactive rebase, an insanely powerful tool I really want you to check out after today's talks or maybe after the DevOpsStars conference. We learned about force pushing, and we learned that this is something dangerous you should not do if there are more people working on a certain branch. If you know what you're doing and your team is aware, or maybe this is part of your workflow, it's fine. Just talk to people about this before you do it. There is a middle way I haven't talked about due to time constraints, and that's the git commit -- fixup option, which lets you commit a new commit that contains fixes for another commit. So this will simply append a commit you can push without force pushing, and then later you can call this rebase - auto squash, which then will apply those fixes to the commits you specified. Just I wanted to point this out. Check it out if you think this is something interesting. Again, first aid options, of course, exist. If you should screw up your history, you can always, if you have not yet pushed, fetch the history that is in remote. This will pull the changes into your tracking branch of the branch you're currently in. And then you can reset your current state to this history as it is, for example, on GitHub. So this would be the tracking branch of branch name. The -hard option will make sure nothing's left of what kind of changes you introduced. After this command, your local history will resemble that of your remote. Another cool command is the reflog command. This will let you also access commits that you previously overrode. Again, very powerful. Also, if you are in a pickle, read the documentation or write me a message on LinkedIn. Now, one goal left to talk about. We don't have a lot of time. That's why we skim over it a bit. There's no demo on this. But what you can do again with the rebase command is you can verify that each and every command works. For example, if you pass this -- exec option, you can pass something that will run your tests. And while the rebase is stepping through your commits, this command will be run after applying each commit. And if this command fails, the rebase will stop. You have the chance to fix this, the content of this commit, and then continue. And that's it. Now you know how to incorporate feedback, how to make small commits, how to change history, again, to incorporate your feedback. And now you know how to make sure that each and every commit works. I hope you wrote all this down because, no, just kidding. There's a handout. Feel free to download it. And yes, if you have any questions later on, I'll be part of the Q&A. But of course, you can also write me on LinkedIn. Thank you so much.
Oh, hey, Rui, you muted.
I'm very sorry, Rui, I muted you. Now I can hear you again.
Thank you very much, Johannes. Great presentation. Thanks
a lot.
Thank you. So our next speaker is called Javier. He's from Argentina. He's the CEO of a company called Crowdor, and he will talk to us about testing in DevOps. Very interesting thing. So, be welcome, Javier.
Hi, Rui. Thank you.
The stage is yours. Thank you.
Thank you. Let me share you my screen a little bit. Okay. I think I'm sharing now. Thank you, all the team in DevOpsStars to let me be part of this presentation. I'm very proud of being in this important event. This is our first time in a US event, so thank you for letting us be part of this event. So let's talk about a little bit about DevOps and testing in DevOps, which is the topic that we work very, very frequently in our projects in Crowdor. So I try to be as quickly as possible to let them space for making questions at the end of the session. So basically, looking at the current software development challenge that we face today, most of us will agree that digital transformation, especially in the last 2 years, was a critical one, and that move forward or challenge us as a technical people to develop software and make all the development process around this more challenging than before. So the implementation of agile and DevOps methodologies is more frequent now. There are more fast changes, so there are more demand for frequent changes. Everything all the time was fast requirement for the business, but right now I think is more and more frequent. But there's a couple of additions that are important to include into the challenges that are security. Everyone must know that with the current threats in cybersecurity, the security is not optional anymore. We cannot rest on the decisions that we made. We have to review that frequently and have it into account. And performance as well matters a lot, because with the amount of changes that we are making to the software that we build, anything could affect performance and has to be taken into account. All of this challenge, I think, that makes DevOps as the best solution and to develop software right now. I think for me it's not a matter of choice right now, which is the methodology. Obviously, it's a process that the teams has to follow, but I think that the DevOps culture is the model that we need to follow. So most of you must be familiar with this picture. That at the end is a matter of interconnect and interchange between different roles in the software development process. So we have to plan the code, we have to code, we have to build, we have to test during the process, release, deploy, operate, and monitor. Everything has to be done continuously. So that's the main difference with the previous process that we follow in the past, like mostly agile or even waterfall approach. So right now, all the roles are interconnected and interdependent between each other. So they have to be connected, communicated, and in the right way. So going deep on this, what do I think is DevOps? I would like to bring you some definitions that are interesting or acceptable for me. Probably there are more sections of DevOps, but I think these are the best representative definitions that we can choose. So it appears as a response to intrinsic drawbacks of organization structure based on functional silos. What we say that because in the past and even now in most of the companies, there's the organization structure of the companies having development teams, quality teams, operations, security as a separate organization units, makes that the communications and the objectives between the different areas probably are not the same all the time. So that makes problematic somehow about the needs and the priorities of each team makes sometimes that generates problems between the different teams and the objectives. So why we think that these problems appears? Because having different incentives, of having different approaches in the areas of the people belong, generates that sometimes the added value to the product is not always the first priority. So again, what we think is that compared to the traditional approach before DevOps. So we need to eliminate those silos, right? I think that the separation of the areas between different responsibilities, as I mentioned before, development, QA, security, infrastructure, etc., make difficult the communication, and sometimes the objectives are not the same. So open and assertive communication is critical to having a DevOps culture. Have a teamwork spirit, have aligned incentives and responsibility. That's what I mentioned before. If we align the incentives of the security area, for example, like having 0 critical vulnerabilities in all the software that we develop, and probably having a small vulnerability in one software, a piece of software that has to be delivered, that incentives are not aligned and probably will create an issue in the deployment of that small solution. So having that alignment is critical, and they have to work together, not to be stoppers of the process of delivering value to the customer. Another important thing that we face all the time in our customers and in our projects is understand that the failure is part of the process. It's not something to be punished. It's something that we need to take as a learning in the process of development in this way. And failure is part of that, and we need to move ahead quickly, understand the root cause of those failures, and improve the process. So continuous improvement is very attached to that concept of having failure as part of the process. Respect the others' opinions. I think it's important to understand that there's no stars in the team, right? We know, and having many years in the development industry, we know that sometimes there are heroes, or there are profiles of people that are very important for the teams because of their technical capacity or the abilities that they have. But all the opinions in the team, including all the roles that I mentioned, are important. So having into account the point of view of all the team members, not just developers, infrastructure team, security team, and testers are important. So all of them has a different role, have a different point of view, a different technical skills that has to be taken into account to avoid these problems. And for that, it's important to generate a trust environment. We cannot do this without a trust environment and without having clear rules of that we don't want to punish the mistake or the failure. We need to understand that and we need to demonstrate that with a matter of attitudes between the teams. This is not just saying that we respect the others' opinions and failure, but then when we have a problem, we punish that person and reduce the confidence on that. So we need to demonstrate that we are confident and we respect the failure and we can create a trust environment, because otherwise the people that find problems usually will stay shy and we probably don't discover all the problems that we have in the process of development. And finally, and not less important, is customer focus. Customer focus is very important because we need to focus not just in security, not just in performance, not just in functional behavior, but we just focus as a whole team of development and operations to provide value to the customer. If the things that we develop don't provide the value, but they are perfectly running in the infrastructure with security, performance, etc., it doesn't make sense to develop that. So what is not DevOps? I think an important thing, and I will move more forward quickly, it's not, DevOps is not an IT problem, right? Usually it's happened like that, or it seems like that because appears or is promoted by IT, but it's not the entire responsibility or problem of IT. The entire organization has to be embraced with DevOps culture and principles that I mentioned in the slide before. So IT can be the catalyst of this behavior and this culture, but not the end. We don't do DevOps to say we do DevOps. We do DevOps because we think it's a matter of improving the value, improving the flow of bringing value to the customer, and we think that is a better way of building software, basically. So business has to be part of the change, not to be a spectator of the change. It has to be part of the change, be involved in the change, and the stakeholders has to adapt to that and be part of the paradigm. So people participation is essential. So again, what is not DevOps that probably are, I think, a common misunderstanding in the industry is not a role within IT. It's not a DevOps role. Basically, that's a deformation of the term, but there's no DevOps engineer. Usually, we find we accepted terms like DevOps engineer as the person who knows how to automate pipelines or automate deployments or automate implementations of Kubernetes in the cloud, or they know but it's more a cultural behavior. Also, there's no DevOps area because it will be a contradiction of what we said until now. And it's not the people that manage the CI/CD pipelines. It's reducing to that is a very simplistic approach, but it's all what we mentioned before. And it's not the one that do automation. DevOps is a culture change and where trust, confidence, failure as a learning process, and collaboration is based. So, what is quality in DevOps? So, moving forward with the topic of this talk, as well as we say that we need to include all in the same page, not just developers and IT and operations and security. We need to include QA as well. Sometimes happens that in agile process that QA development teams do the work, they build software, and then by the end of the sprint they left QA a small amount of time to do their job and validate the quality, functional or non-functional behavior of the application. So adding QA, IT and operations and InfoSec as part of the team with the same responsibility that the developers reduce the friction of the team. So the whole team is responsible for the QA, for the quality, for the security, for the performance, and for the functional behavior of the application. Having that in mind, is possible to build a trustable environment, a good sense of behavior of the people to the team, and be responsible as a whole team with no difference between one role or the other in terms of responsibility for the value. And I like to mention this paragraph of the Phoenix Project, which is, by the way, a great book to understand DevOps and DevOps culture. So, what is the essence of quality in DevOps? Basically, the first bullet, I think that is a good synthesis of what we expect from quality. Having automation and having a process to develop, build, package, and deploy software faster, we need that feedback to let the development team to correct the things that they write code and write problems very quickly. So the feedback is essential. As much as faster as we give feedback to the development team, the better the solution. And when I say feedback, it's not just say, okay, this is a bug, this is wrong, this is not working. We need to state clearly what we found as a QA people into the software, and not just doing manual testing or functional testing or automation. We just also need to add performance, security issues, and we have to be capable to do that. So following slide, I will talk about that role needs more deeply. So avoid the silo and work integrated with the team, with product owners, developers, site resilient engineers, infrastructure, etc. So quality is be part of the team as the same as we ask to be integrated in the team. A member of the team, like the QA people or the testing, has to be the responsibility of be part of that integration. So everyone in the team has to be responsible of that integration and collaborate to that instead of moving a part of the problem. So avoid the bottlenecks at the end of the sprint. It's doing a sprint of development and use the last 2 days of the sprint or the last day and weekend of the sprint to do testing is not a good approach at all in DevOps or even in Agile. It's something that has to be avoided, and we need to shift left as much as possible the testing process. So moving forward and early testing, not just manual but also automation testing, is critical to finding or to finalize the sprint of the piece of software that we deploy in each commit as better quality as possible. Why? Because we need to accelerate the feedback and to avoid the distraction of the developers later on. If we do testing later on, after the deploy and after the finalization of that feature, probably we find problems that our developers are not in the focus right now to solve. So we need to accelerate that process as much as possible using tools and using techniques that accelerate that process. Integrate non-functional tests is what we mentioned. Do performance, security, accessibility, and usability all at the same time, not leaving that for the end of the project because it's less important than the rest of the functional behavior. So if we talk about a little bit about automation, where we are having a lot of experience doing this, this is a Martin Fowler approach that has a couple of years, but I think it's still valid for some environments right now. So based on a traditional or old approach of finding bugs, unit tests are low, and we have a lot of tests in the top of the pyramid or the inverted pyramid. So we automate somehow. We have some small unit tests, but we make a great effort in the manual testing. This is not so sustainable in a model of DevOps where we need to deploy functional software in question of minutes or days or hours. We need to change the approach. And how we can do that? With an approach of preventing bugs. So making a big unit test, if we can move forward to TDD approach, will be best of the scenarios where we write the test before writing the real code. So as soon as our code is ready, the test will pass and the software will run. But also to complement that, we can write tests in different approaches or different sections of our software, right? We can do component test automation, we can do integration automated test, we can do automated API test, but with behavior, not just checking the API. And finally, we can do UI automation test. The pyramid has that shape because the effort of doing unit test compared with doing UI automation test is less. So this is the recommendation, to write as much test automation as possible, where it's simple and easy to do and easy to run. The UI automation tests usually take 4 times the effort of writing a component test automation. So if we don't do this, we need to make this bigger, and it's a lot of effort and a lot of time consuming to execute that. So then finally, exploratory testing is not forgotten in this model. We have to include it anyway. And the combination of all these approaches will prevent bugs and give us an agile testing approach that is more fitable to the DevOps environment. So if we look at the process, sorry, there are some Spanish terms here. If we look at the development process as a process itself, not just a practice, we can see that during the development process and building unit tests, we have to start very early in the process to do exploratory testing and functional testing. Even in development environments, we have to do this early on to accelerate the feedback to the developers, but also start to do automation, at least writing scenarios or do mocks or do different kind of tests that we can start very early in the process of development. So if we do this in parallel, we can guarantee that at the end of the sprint, we can have a decent kind of testing process in DevOps environment. So after a sprint finish, we can do an integration test manually, exploratory, but also combine all the automated tests. That doesn't mean that we cannot run this test in the middle of the sprint. We have to do that. We have to run this test, no matter that are incomplete or all the pieces of software are not developed yet. For that reason, exist mocks, contract tests, etc. But as soon as we, as developers, start finishing features, we have to be ready to test that, not just manually, but also automated. If we have a clear definition of user stories, acceptance scenarios, acceptance criteria, we can start very early writing scenarios to test these features. And as soon as we start testing this, we can give more value, and it's a virtuous circle that embrace the quality in the process. Obviously, we can include a small performance test at the beginning of specific features and security scanning as well as code quality. So if we invert the focus of this and looking based on a pipeline that is very common on DevOps practice, where we build, this pipeline is an automation process to build, package, deploy, and test software. We see a lot of tools that we can include in our set of tools, including functional testing and including automated testing, not just unit testing, but also automated testing, doing contract tests, etc. All the tests that I mentioned before. And we are very fan of using Cucumber or BDD as a support of this test, because we'll democratize the understanding of what the software has to do and how to test that process. So what are the skills that we think that QA people needs to have in DevOps? And this is my last slide, and then probably we can join for Q&A in the following session. Having all that I mentioned before, we need to understand that the QA or the testing people have to evolve in their roles. It's not the same that it used to be, and the challenge are bigger and more technical. So right now, having knowledge about shift left practices of what I mentioned to accelerate the testing as much as possible, implement this virtual cycle that we think is a critical aspect, starting from user stories, acceptance, having acceptance criteria, writing test scenarios, and then automation and monitoring those scenarios is critical for the testing role. Having knowledge about test automation, right now, having all this process of automation that I mentioned before, we have to understand at least how this can work. Probably you don't need to do coding of test in particular, but you have to understand what you are using. So you have to know how to use this test automation, no matter if it's a developer or it's an automation engineer who write the code. You have, as a tester, you have to understand how to use it, how to understand the reports, how to understand the results, and then if a bug appears, has to understand the real or the root cause of that. In the pipelines, all these pipelines, it seems complicated, but it's not that complicated if we understand. And if it's something that we need to understand where is the problem, and when the problems appears, how to report efficiently and to give feedback quickly to the team that has to solve that. Work integrated with DevSecOps. QA is not isolated of all the things that I mentioned. Security, operations, development is all part of the same team, as well as QA. Knowledge about reading logs and monitoring, having the tools as a critical thing has to be part of the tools that someone in QA in DevOps has to know, and understand performance and security as well. So as I mentioned before. So that's all basically that I have to present. These are the services that we deliver with CrowdArk, just to let you know about us. We do all these services, test automation, performance, security, but also we do DevOps culture hands-on, and we implement deployments. We do coaching as well, and we develop tools. So we develop tools to accelerate that process that I just mentioned. So I invite you to take a look at Lipia. It's an open source project that we developed during our experience and we use very frequently. It's open to download and read and use the code. So I invite you to all the audience to take a look at this and I encourage them to use it. So thank you. This is all my contact points, my email, and all the websites from Crowdar, Lipia, and the Crowdar Academy, which is a tech school that we launched a couple of years ago to teach people to do testing and RSE in the and be ready to a new job. So thank you, Rui. I don't know if we are okay with the time. Thank you for the opportunity. You're on mute, Rui, I think.
I think that not anymore. Thank you very much, Heather. So I think that we can go directly into our session of questions and answers.
Okay.
Let me bring some of our guests to. Hi, Johannes.
Hey, everyone.
Hi, Johannes. Nice to meet you. Hi, David.
Hi, David. Hi, Dean.
Hello.
Hello, Dean.
Hello. Hi, Ignacio.
Hello, everybody.
Hi, Jorge.
Hello, everyone.
Let me see if I think that I haven't forgot nothing. No one, sorry. So we have several questions very interesting here that were sent through the chat. And please feel welcome to answer if you want to add another view or you would like to have a different vision of another colleague, please feel free to it. Okay. So the first one that I would like to bring to you is, what's the difference between DevOps engineer and SRE engineer when it comes to work? Feel free.
All right. Sorry, I didn't know how to jump in.
Okay.
As we discussed in the past, so this is my personal opinion, by the way, and feel free to disagree with it. DevOps is a set of culture and a set of principles, similarly to Agile, for example. SRE is a really well-defined engineering arm by Google, and that SRE engineer is a good job title. DevOps engineer is an industry-wide job title, which I really disagree with because you don't call anybody agile engineer either. However, I think what they are trying to say with it is DevOps engineer in an incorrect way defined as people who are practicing DevOps. SRE engineer is a software engineer who is trying to implement automated software engineering capabilities utilizing DevOps principles.
Okay. Who would like to add something?
No, I totally agree with these colleagues here. Yeah, totally agree. DevOps engineer is a matter of something that I think that the HR industry, recruiting industry created in somehow, but obviously SRE is a proper definition or a more close definition, more built by Google. Yeah, built by Google, but I think that they define the role more clearly. And if we think that we just talk, and I think that the guys mentioned the same, the DevOps is not something that an engineer can do by their own. It's a matter of the collaboration between the teams. As if we hire a DevOps engineer, we can have DevOps just because of that. If we can do that, we will be very, very lucky, but I don't think that is a reality. So I agree with the concept completely.
Nice. Yeah. Okay, let's go to another one then. This one is for Jorge and Ignacio. What do you consider to be main selling points for GitOps compared to other methodologies?
Okay. Do you want me to answer, Ignacio? Or yeah,
no problem.
Okay, so the main selling point is to ease the operations, and I think that having your operations in a controlled manner and with in a only or in a place like a Git repository and working like a developer doing in the day by day is the main point. So you can accelerate, you can avoid human errors, you can make rollbacks quicker, and I think that's all. It is very related to operations and the way that you are deploying. It is tied to DevOps, but it's, for me, it's more like on the operation side, and it's just the new way of managing the modern infrastructure like Kubernetes. So I would say.
Yeah, for me, the point is that there are not other methodology to do that. I mean, this is the natural evolution of the way that you manage your infrastructure. So it is what it is, and you should do that. The other alternative is to do it more manually, and that's all. I mean, so it is what it is when you start to work with cloud native architectures or Kubernetes related architectures. This is of course the efficient way to do it. So
interesting. Anyone would like to add something?
Yeah, maybe it's not a main selling point, but I think it's also something younger or new developers are very much used to, because GitHub Actions, GitLab CI, it's basically GitOps, right? You update your YAML, you can track it with Git. Yeah, probably people would be confused if you told them you have to do this stuff manually. So yeah.
I think, you can add another layer into this. Is the whole motivation, in my personal opinion, is the enablement of taking ownership. If one team who is design something, have the capability, they are enabled to be able to go through all of the steps themselves. The reason why all of these technologies are defined as code, self-service, and have configs in order to run is because it all comes down from a development point of view. Can I repeat the same action in multiple different environments in the most simplest manner possible? So the same people who design it and build it are the one who's going to test it. They are going to be the one who run it. And basically, I think this is the enablement side of things. And DevOps is a good methodology to help that kind of mentality come to life.
Maybe to add to something else, we've heard it before. DevOps is a kind of a culture thing, right? Git is a tool that can help you, live this culture. I think very, very well, because you can take a step back. You can learn about the history by going through the Git history, and if this ties into your deployment workflow, for example, this is just insanely useful, I think.
Okay. We have one more technical question here that is related to it too.
Yeah, I think that question was during my talk. I mentioned this quite briefly, maybe, but you can change some previous commit in your Git history. If you want, I can share my screen just a second, and then I can just simply show it again. We will have some duplication now. Can you? So now we are Can you see it? Can you see my terminal?
Yeah.
Yes.
Perfect. So again, we start in interactive rebase again on the main branch. So this just tells us we are working on these 3 commits. And now if I want to change some of these commits, I can simply do an edit on these commits. I also showed this, I won't go into detail here, but basically what now happens is once I save this, the rebase will stop once we are at the commit we want to change. Then I can change the commit, and then yeah, I can continue the rebase. I hope that answers the question.
Thank you. Thank you. This one will help a lot of people. Hi, there are many software around. What is needed to begin with as a junior DevOps?
I'm going to start here, but of course everyone should add something. But I think that in terms of DevOps, it's not a question, as my colleagues said before, it's not a question about tools at the beginning. It's more a question about understanding the concept that is behind the term DevOps and what it means in terms of culture, but not only a culture for a big company, but I mean everyone that starts to work with new technologies around cloud and start to develop something should at least understand the principles of DevOps just to have an easier life in terms of create your pipelines, automate everything in terms of deployment of your applications, so you don't have to care about the normal operations that some years ago you have to check manually. So it's a question about optimize time and become a better developer, or become a better architect, or become a better operator. So after that, you have tons of tools, and you can make your selection about what fits to your needs. But first of all, is to understand what it means. But as we said before, it's not about become a DevOps engineer itself, more to understand the principles and to adopt it to your needs and to your solutions. That's my opinion.
Okay. I think that the people doesn't understand when they come to the market that we have much more a culture of development than the use of tools for development. I think that the recognition of the culture necessary to understand how works the structure of the DevOps is much more necessary than to learning to use tools. What do you think about it?
I could say that I agree with that, but also at the same time, being a technology company that not just provides services but also build products, I think that the bar is higher than before. So it's not just about it. It's right that the culture is something that you need to understand before, but it's like the kindergarten. The kindergarten is the culture, and then you need to learn how to write and how to read with the new tools, because otherwise you cannot execute the culture, because you are an alfabeto in Spanish. you know how to read and write, right? It's important. So I think it's a matter. It happened to us in particular where we build software in a microservices architecture using Kubernetes, and we failed continuously. we made mistakes all the time because we think that we are doing the right things, and sometimes when I have to do a demo, I have this bunch of features without deployed to the production environment that we used to do the demo, and we say, oh, we have a problem. We sell this, but we have this problem at home. So it's something that you need to know at least some basic tools, understanding a pipeline, understanding how it works, a pipeline, understanding how Git work. Anyway, probably you don't need to do what Johannes made in the demo. Probably it's too advanced, but at least you need to understand what is a branch, what is a merge, what is something. Work with these tools because it's a new set of tools that I think that one of the things that makes all these RSE engineer roles so demanding, because the understanding of this set of tools is not science fiction, but it's difficult to find people that understand multiple languages, not just YAML or Git, but also having some basic knowledge of development to do infrastructure as a code, for example. So it's a matter of culture, but you need to know more than that. I think that's my conclusion based on our experience.
Just to build on what Javier said, so basically, if the question can be interpreted in a way that what are the tools, type of tools, which you may want to start with, is version control, is pipeline, is declarative orchestration, is utilizing anything where you can demonstrate and test out how an immutable infrastructure, an idempotent deployment looks like. If you understand that and actually try to achieve it with whatever tools you like, you're already gaining experience. There are hundreds of tools out there which capable of doing it. If you know what they're for, you can then put it to the right box.
Okay. Let's shift our point of views. We have an interesting question. What are the most common obstacles when implementing unit tests? Who would like to say something?
Go on.
Yeah, well, no, I can say that is, I think that the main obstacle is to understanding why you have to do unit tests. I think that the main problem usually is like the developers, who in my point of view are the responsible to write unit tests, see unit tests as a demand from the organization, or as a demand like a good behavior, right? It's not a tool, like, or they don't, probably the developers that don't do unit tests probably don't perceive the value of doing unit tests early enough. And when they have to do it, it's later because they already write the code, and it's something else that they have to do to deliver what they built. So they see like a decoration, I think. So the one good approach, and I'm not saying that we are doing that, because as I said before, sometimes we have the same problems internally, but one good approach is to make the opposite process. So write the test before the code. So if you want to do unit tests correctly, you have to write it before, in advance, not later on after you have the code running. So with that in mind, you can use it as a tool to test your code. And if you see like that, you give value to that. Otherwise, it's something else that you have to do before deploying your solution. That's my perspective.
Okay. Also wanted to just add to that, when somebody asked me this, and I literally had this question came a couple of hours ago from somebody else, and that's why I was smiling big time, because basically we broke it down. Well, code quality, define success criteria, dependencies, all of these things, which makes it super hard. And this is internal to us and to my own personal experience. But every single time we're trying to do it right and we start building it, is, what's the code which you are trying to test and how is it written? And if that's not written intentionally in the right way, then it's super hard. It comes back to what Javier said. If you do an exercise test-driven development, which you refer to, it's much easier. If you don't, retrofit it, super hard. Success criteria, you do the test for, again, as Javier said, why are you doing it? If you don't know why, you just run a test and that's meaningless. Why are you even bother? And when you have both, but you have a service which has so many sub-dependencies all around, you don't do unit test, you do the integration test at the end. So it is super, super hard if you were not prepared to do it from day one. That's probably my opinion.
Yeah, I agree with both of you. I think that the developers, most of them, do the unit tests as an obligation and not as a tool to gain in quality and results. And we have several difficulties that are related to the point. Well, let's go for the next one. Is SRE position considered as shift career for a software developer with experience 9 years? What do you think?
From my opinion, I don't think it's a shift career. So I think it's like a movement for taking maybe more responsibility, but in the way that you are in charge of keeping the lights on. But it's not a different career than a software developer. Maybe you have to go deeper into the infrastructure topics and so on, but I wouldn't say that it's like a shift. I don't know what you guys think.
I mean, I can just applaud you for that comment, because that's literally what I was thinking as well. Like SRE, as we said before, is the software development approach to automation, to operational problem. SRE is primarily developers who are focusing on infrastructure and focusing on this type of automation and testing, but they are still developers. It's a bigger shift if you try to go from a traditional operation to SRE, because you must learn into the development practices. And that's a bigger shift. That's what I would call a shifting. If you are a developer, you just change your focus to the bits which you were less focused on before. But you're not changing. I honestly think you're not changing your role. You're expanding your point of view. Meanwhile, from an operation to SRE is actually changing the role.
Okay. We have one more question directly to David. David, can you elaborate on zero-touch automation? It sounds great, but it sounds difficult to achieve in an already established organization.
I'm not sure why we say it's difficult. It took me 3.5 years to push it through. So yeah, basically, zero-touch automation was one of our biggest dream when I joined, and that was one of our big objective. Means that we want to make sure that when you choose, so you know this famous statement from Netflix, which is why they said that their goal is that whichever developer joins on day one, they can push a code and it will arrive to production on the same day, or not, because the test will catch it. And that was the whole point. This is what we wanted to achieve as well. So dream big. The zero-touch automation means that the entire cycle from merging the code up until it goes through all of the tests and reaches production, gets deployed and gets validated, it is without a human interaction. So it's multiple CI pipeline connected with CD, with your unit test, with your DVT, with your synthetics and user validation, all combined together, including the fact that production is locked down and no human can manually bug around there. And that's what I meant around zero-touch automation. It is super difficult because of two things. If you already have an established pipeline and process, it is really hard to change people's mind and retrofit it. So to be fair, what we've done is we created a new production account. We created a new set of capabilities from scratch, prove that they are identical to be able to host in infrastructurally and architecturally. Therefore, we moved it over. But when we moved it over, all of the infrastructure code and all of the automation was in place. So instead of trying to retrofit it back, we built it again with the same requirements, moved over, hosted it, and literally just switched over. That was an easier step forward. It still does not account the people and policy sides, which is much harder, but technically that's what we've done.
Okay, thank you. We have space for one more question. I would like to have one short answer for each one of you for this. Do you believe in having extensive test automation on non-productive code, as in performance, security, accessibility tests running in CI on DevOps infrastructure code? It sounds good, but rarely do companies do that. Do you believe it?
Can I start in cracking it? My opinion there would be, sure, if all of them are self-service, then you can make a decision what is needed for you. Should all of these options be available for you and for your code to run it on a non-production place? 100%. Should you run this every single time for every single one of them? Definitely not. So, in my short answer, opportunities should be there. You should be able to decide whether it's meaningful for you or not. You should be able to do it, but you shouldn't do it all the time.
Okay. Who would like to add something?
I would just like to agree, basically. it depends, right?
Me too. Me too.
Yeah.
Okay, dearest ones. So thank you very much for your presence, for your insights. It was great to be here with you. And I think that we have another announcement to run now, but I would like to give my thank you for each one of you. Thank you very much.
Thank you so much for having us.
Thank you, team.
Thanks for
Thank
having us.
you for the opportunity.
Bye.
Nice to meet you all.
And thank you, Rui, for moderating this block. We'll actually see Rui later today. He's one of the speakers today for the last block of the conference. And I'm just here to tell everyone that, for those of you who are watching on our platform, please stay there. We'll continue right there. And for people who are watching this on YouTube, we're going to switch to a next link of the conference. I'm posting it to the chat right now. Please don't leave. Please don't miss. This live stream ends, but the next one will start right away after the quick video. So stay tuned.
And now we want to say a huge thank you to one of our platinum sponsors, Sysdig. So the Sysdig Security DevOps platform provides security to confidently run your containers, Kubernetes, and cloud. Secure your build, detect and respond to threats, and continuously validate cloud posture and compliance. Maximize performance of your product and availability to monitoring and troubleshooting cloud infrastructures and services. Sysdig is a SaaS platform built on the open source stack that includes Falco and Sysdig OSS. They open standards for runtime threat detection and responses. Hundreds of organizations rely on Sysdig for security and visibility. To use their free trial, sign up via the link that we will post in the channel. And you can join right now and start for free.